Check. All right, people. I believe everybody is doing great, nice, and absolutely fine. Welcome to this beautiful session. Welcome to Unacademy NEET English. And if you have not subscribed to the channel yet, hit the subscribe button. And most importantly, do like this session, okay? I want you guys to smash the like button as soon as possible because that's mandatory, okay? Let the people join and we are starting the session. We'll be killing the best of the best problems in the today's session. Okay. And what's up? How is everything going? Tell me in the chats. Light up the chats with the fire emojis. I want you guys to burn this chat box out there. Okay. So I believe all of you are doing great. Today is our second lecture. Back over here in front of you with the same energy. Okay, I'll be sending the PDF of the yesterday's session for sure today only, okay, in our Telegram channel. That's Unacademy NEET English. Don't worry about that. That's my job. I'll do that. Okay. So let the people join and we will move. Make sure you hit the like button. I want everybody of you to like the session, okay, as soon as possible because that is mandatory, okay? This like count should cross 1K as soon as possible. And guys, listen to me very carefully. This is the top 500 questions, okay, over here. They are less than 500, okay. But when it comes to the problems, I'll be showing you every pattern of problem which has the probability to ask in the NEET 2024. We'll be solving every pattern of questions out there, okay. And second thing over here is, I say, I want you guys to make the notes along with me only. And the rule is before I solve the question, you guys are supposed to solve it. Okay, that's the rule. Now, my dear friends, listen to me very carefully. Before this session, I want you guys to exactly focus on this thing. What is this? This is the All India mock tests, okay? I want you guys to join this All India mock tests on Unacademy. It is completely free of cost. You don't have to pay any sort of money. The link is in the description below, All India mock tests, okay? You can join that. If it asks for the code, you can use my code Yavar. If it doesn't, just enroll directly, okay? You'll be getting best of the best mock tests completely free of cost, okay? We are making these mock tests, okay? You people basically trust us. So we make these mock tests for you guys, okay? So I don't want you guys, if this is free, join it, okay? Jo milta hai le lo. So take this mock test as soon as possible, okay? Enroll it. The link is in the description below. Now, let's move on to the first question that we have exactly on the screen. The first question over here is, I am asking you, I say, find the net force on the center charge. I want you guys to tell me what is the net force on the center charge over here. What is the net force on the center charge? Everybody out there, what is the net force on the center charge? Don't say zero. It is not zero because see, it is minus q, plus q, plus q, plus q. Listen to me very carefully. If it was something like this, like you have got plus q over here, you have got plus q over here, you have got plus q over here, you have got plus q, plus q, plus q. Okay, and at the center you have got whatever, plus q, minus q, 2q, whatever it may be. If similar charges are present on the corners of this particular structure, if similar charges are present like plus q, plus q, plus q, plus q, plus q, then we say net force on the center charge is 0. In that case, we say net force is 0. But you can clearly see it is minus q, minus q, minus q. And Over here we have plus q, plus q, plus q. So on center charge, you cannot say net force is 0. Net force is only 0, my dear friends, if all the charges which are present at the corners are similar. Then in that case, we say net force is 0. Now see, what do we exactly say in this particular case? Listen to me very carefully. It is simple. It is simple. I'm saying that I have got this plus q charge and plus q charge. We say, sir, positive repel, so it will repel this in this direction. Okay. Let's suppose with a force F. And this negative charge will also attract this positive charge in this direction. We say, suppose, let's say with a force F. And this negative charge will attract this with a force, let's suppose with a force F. This positive charge will repel this positive charge with a force, we say, sir, F. Now, this negative charge will attract this with a force F. And this positive charge will attract this with a force F. And my dear friends, this angle is total 120 degrees. Tell me, can I make this figure over? Can I draw these forces over here? We say, sir, in this direction, we have got F and F, that is 2F in the same direction. We say, sir, in this direction, we have got F and F, that is once again 2F. We say, sir, in the forward direction, we have also got, we say, sir, 2F. Tell me one thing, sir, if the angle between these two is, if the angle between this and this is 120 degrees, if the angle between this and this is 120 degrees, can I say in that case, sir, resultant of this one and this one is also, resultant of this one and this one is also, we say, sir, 2F? Because I have told you in the last class, if we have got a vector, if you have got another vector, let's suppose this is F and this is F, their angle, if angle is 120, their resultant is also F. So we say this is 2F, the resultant is 2F. Now, could you please tell me how much will be the net force over here? You say, sir, net force will be now, sir, this and this having 2F. Now this 2F and this 2F is exactly equal to 4F. This 2F and this 2F is exactly equal to 4F. Is that clear? 4F, yes. And we say, sir, 4. What is the value of F? F means force between any two charges. So that you can say, sir, K, Q1 you can take this, Q2 you can take this, sir, Q, this small q divided by, what is the distance between the forces, distance between the charges over here, that is A square. So this is the net force in this particular case, okay? Keep this thing exactly in your mind. Let me show you one more beautiful question. See, let's suppose you get a question something like this. This is a pentagon. Previous one was the hexagon. This is a pentagon. Previous one was the hexagon. Okay, we say find the net force on the center charge. Center charge. I want you guys to tell me the net force on this center charge. How much will be the net force over here? Find the net force on the center charge. Everybody out there, tell me how much is the net force on the center charge. Guys, I told you, see, the logic is simple. The logic is simple. If you have got similar charges on the corners, okay, like you have plus q, plus q, plus q, plus q, plus q, identical charges, even if it is 2q, 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 then also. So we say if you have got identical charges at every corner, in that case, we say, sir, net force on the center charge is 0. In that case, we say the net force on the center charge is 0. Simply, you don't have to go in the logic. Okay, directly you remember net force on the center charge is 0. If you have the identical charges on the corners. Now, let's move on to the next one. Let's suppose you have got this question. See, in this case, you have plus q, plus q, plus q, plus q. But at this corner, which is at the top, you have no charge present. There is no charge present over there. I am asking you the question, find the net force on the center charge. Find the net force at this center charge. Okay. This is a very good question, actually. I want you guys to basically give it a try from your end. Okay. So it is, let's suppose something like this, plus q, plus q, plus q, and this is plus q. At the center, you have got minus q. There is a trick which you actually use over here. Yes, a lot of people are writing F. Very nice, very nice. Now see, how will we solve this question? See guys, at this particular corner, can we say, sir, there is no charge? Sir, no charge means I can say, sir, net charge on this corner is 0. Yes, sir. Sir, we can also say one thing. What is that? That is over here. Let's suppose it is plus Q. It is minus Q. Hey guys, let's suppose I have got the rod. Remember this concept. If I say on this rod, we have got plus 2Q charge and minus 2Q charge. Sir, how much is the net charge on this rod? You say, sir, in that case, net charge is 0. Why? Because the amount of positive charge present on the rod is equal to the amount of negative charge on the rod. So net is 0. Similarly, either you say Q net is equal to 0 over here, or you can kind of say, sir, plus Q is present at over here, or and minus Q as well. Now tell me one thing. If I say one small thing, what is that? Sir, because of these plus Q, 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 plus Q. Sir, net force on the center is 0. Because of this, net force on the center is 0. Yes. But what remains over here? Minus Q. So, if because of all of these charges, net force is 0, which that we already discussed, because of this minus Q, it will attract it towards itself with a force F. So, in this case, we say, sir, net force in this case is F. And that you can call as F is equal to K Q divided by R square. Let's suppose this distance is R. Hey, tell me in the chats, is this clear? So what is the trick that we actually use over here? We take plus Q and minus Q. Because of all the plus Q's, net force is 0. And then what remains? Minus Q. So because of the minus Q, force will be there. Okay. Let's move on to the next question. Now, I want you guys to take a look over here. Hey, is this clear? Tell me in the chats. Light up the chats with the fire emojis. Everybody out there. And if you have not liked the session yet, I want you guys to like the session. Mark the attendance. That's mandatory. Like the session as soon as possible. Let me know in the chats. Light up the chats with the fire emojis. Everybody out there. Yo. Okay. Now, this is the question that we have. 3-point charges plus Q and minus Q are placed at the corners of an equilateral triangle. Okay. Let's suppose we have got an equilateral triangle over here, something like this. Okay. It is saying that plus Q and minus Q, plus Q and minus Q are present at the corners of an equilateral triangle of side A. This side is A. Another charge plus Q means is capital Q, is present at the centroid, is kept at the centroid. We are supposed to find how much is the force on this center charge. How much is the force on this center charge? How much is the force on this center charge? The options are exactly given over here. How much is the force on this center charge? The options are given over here. See, guys, sir, this plus Q will repel this plus Q, something like this with a force, let's suppose F. Sir, this plus Q will repel this plus Q, something like this with a force F. Okay. And then this minus Q will attract this plus Q towards itself with a force, let's suppose F. Okay. Guys, remember in this triangle, we said this angle is 120 degrees. This angle is 120 degrees. See, I'll make it over here. Sir, one force is, let's suppose F. Another force is, let's suppose F, this one and this one. Okay. And another force is, we say, sir, this is also F. Now, angle between this one and this one is 120 degrees. Okay, this is 120 degrees. So, can I say resultant of this one and this one will be also F? Yes, sir. So, can I say in that particular case, I can directly say in this case, sir, net force is, we say, sir, F plus F, that is 2F. F plus F, that is 2F. And most importantly, if I just have to write it more properly, we write 2 into. Then what is the value of F? Let me write on the next slide. Let me add the slide. So I write over here, sir, net force in this case will be simply, that is 2 into K. What is the value of Q1? Sir, Q1 is this Q. Q2 is this Q, small q and capital Q. So we say small q and capital Q. Okay. Divided by. Remember one thing, my dear friends. If the side of the triangle is given as A, this distance, remember always, this will be A divided by root 3. This will be a divided by root 3. This distance from this corner till the center, this will be a by root 3. Okay. Similarly, from this point to this point, a by root 2. From this point to this point, a by root 3. So I can simply write over here divided by r square, that is a by root 3, its whole square. Can I say I'll write it something like this? This will be, see, twice q divided by, this will be a square divided by 3, and take this over here, multiply with 3. So I can write it 3 2s are 6. Okay. And then I'll write it something like this. 3 2s 6. This q. This is 6. This q divided by a square. And instead of this k, I'll write 1 upon 4 pi epsilon naught. This will be the net force. Now check which option is matching with this one. 1 by 4 pi epsilon naught 6q cubed by a square. Yes, this option is the correct option over here. Option 2 is the correct option. Yes. Great. Let's move on to the next question. Yeah, this is important. This is very good. I want you guys to exactly solve this particular question. Give it a shot, give it a try from your end. Okay. Solve it, and then we'll move on and we'll solve it. I will solve it also. Come on, tell me which option is correct in the chats, everybody out there. Which option is correct in this particular case? Read the question very carefully, read the question very properly, and then answer these questions. Two equally charged identical metal spheres. We have got two equally charged identical metal spheres. Okay. A and B. Let's suppose this is A and let's suppose this is B. Repel each other with a force F. They are repelling each other with a force F. They are repelling each other with a force F. Okay. This force F. And let's suppose distance between them is R. First, let's find how much is this force. You say, sir, F is equal to K. Let's suppose charge on this is Q, charge on this is Q. That is Q square divided by R square. This is the force over here between the two charges. Then it says that, read it very carefully. Another identical uncharged sphere C. Another identical uncharged sphere C. So basically, we are taking one more uncharged sphere C. Okay. Is touched to A. We are taking and touching it with the A. And then placed at the midway. Okay. It says that, sir, initially the two charges are placed at the R distance. Okay. Then what we are doing is that, let me show you over here. Then what we are doing is that, let's suppose this is, sir, which charge? This is, we say, sir, A charge. This is A charge over here. Charge on this is Q. And this is, let's suppose we say, sir, B charge over here. This is, let's suppose, B charge over here. This is B charge over here. Okay. And charge on this is also Q. Okay. And it says that we are bringing third charge C and we are touching it with the A. Okay. Let's touch this third charge C with the A. And this C is uncharged. And then we place it over here in the midway. Tell me one thing. When we touch this metal sphere with this metal sphere, we say, sir, they will share the charge with each other. So Q by 2, Q by 2. Initially, charge on C was 0 because it was uncharged. Now, when you touch it with this one, so basically charge got distributed over here. Now, this distance is, let's suppose, R by 2. And this distance is, let's suppose, R by 2. This is what the questioner is saying. Okay. Then let's see. Then it says that, then the net force on the C in the direction of. Then we are supposed to say in this particular case, what is the net force on this charge C? What is the net force on this charge C? That's what we are supposed to find out over here. Net force on the charge C. Now see very carefully. Guys, this is Q by 2, this is Q by 2. So A will apply the force on this, something like this. Let's call this as FAC. Force due to A on C. Force due to A on C. Similarly, this B charge will apply the force on this. Let's call that FBC. That is force due to B on C. Okay. Let's find FAC first. Sir, when we say FAC, it is this force applying, this charge applying force on this one. That will be K. Q1 is Q by 2. Q2 is Q by 2. Okay. Divided by distance between them is R by 2 whole square. So can we write it something like this? K Q square Sir, this is q square. 2 into 2 is 4. So I'll write over here multiplied by, this will be r square divided by 4. Yes. So 4 will get cancelled. So this will be kq square by r. This will come out to be kq square divided by r square. Okay. So means this is f. This is f. Because we know, sir, when it comes to kq square divided by r, that we have kept f over here. Okay. Now let's do one thing. Let's find out the force BC, FBC. So we say, sir, FBC. It is simply, when it comes to the FBC, can I say, sir, that will be K, sir, Q1. Let's suppose this is Q1 is Q, Q2 is Q by 2. Okay. Upon, we say, sir, R by 2 whole square, R by 2 whole square. So I can write it something like this. This will be K Q square divided by 2. And this will be R square by 4. 2 1s, 2 2s. So if this goes in the numerator, so FBC will come out to be, we say, sir, 2F. Okay. Now take a look, my dear friends, what I'm trying to say over here. Let's suppose this is, we say, sir, C. On this C, 2F force is acting, this FBC. And this FBC is acting in this direction, which is 2F. Okay. And this FAC is F, which is acting towards right. Okay. This is F. Now tell me, how much is the net force in this case on C, sir? Net force will be 2F minus F. That will be F. And net force will be towards the bigger force. Net force will be towards the bigger force. Bigger force is 2F. So, and it is towards A. So I say F towards A. F towards A. So tell me which option is matching over here? F towards A. Yes, F towards A. Option A. Option A. F towards A. Is that clear? Let's move on to the next one. Okay. I hope this is visible. Find the distance from the 9Q where Q0 is placed so that it experiences the net force. We are supposed to find the value of X. Where should we place the third charge so that net force on it is 0? Where should we place the third charge so that net force on it is 0? Guys, if you have not liked this session, like it as soon as possible because that's mandatory. Tell me. See, where should we place the third charge so that net force on it is 0? Guys, if you have got the opposite sign charges, this is minus Q and this is plus 9Q. Can I say, sir, I use this formula in this case, X is equal to R upon under root of N minus 1. Yesterday, I explained this concept, okay? Where should we place the third charge so that net force on it is 0? So what is the value of R? R in this case is 18. And what is the value of N? N in this case is 9. So this will be under root of 9 minus 1. So that will be 18 upon under root of 9 is, we say, 3. 3 minus 1 is 2. So that will be, sir, 9 meters. Can I say? At 9 meters, you guys are supposed to place, at 9 meters, we say you guys are supposed to place that third charge. So net force on it will be 0. Yesterday explained, I'm not going to explain that once again. Okay, tell me in this case. We have got the plus Q and we have got minus Q. This is plus Q and minus Q. And you guys are supposed to tell me where should we place the third charge so that net force, so that it remains in equilibrium or net force on it is 0. Tell me, where should we place the third charge so that net force on it is 0? Everybody? Everybody out there, tell me in this case, guys, whenever you have, whenever you have positive charge and negative charge, opposite sign charges, what is the formula we use? We say, sir, X is equal to R upon under root of N minus 1. And if both are positive, then we say under root of N plus 1. If both are negative, then we say under root of N plus 1 in that case only also. So we say R in this case is given as R upon under root of N. Can you tell me what is the value of N in this case? How to find N? Divide this charge with this charge. So that will give you the value of N. So n in this case is 1, under root of 1 minus 1. 1 minus 1 is 0, so it will come out to be infinity. Yes, it will come out to be infinity. So means, listen to me very carefully. What I'm trying to say, I'll give you a bit of a feel of this question. Let's suppose we have got a plus q charge and we have got a plus q charge. I'm saying that, sir, we have to find the position where the net force on the third charge will be 0. Sir, do one thing. Place the charge at the center. I say, okay, let's place the third charge at the center. This charge will push this charge in this direction. This charge will, okay, so this is minus q, sorry, this is not plus q. Okay, this is minus q. So we say this charge will attract, so we say both the forces are in the same direction, so E is not equal to 0 over here. Okay. Similarly, over here in this case, we say E will not be equal to 0 over here also. Why? Because this plus q will apply more force, this minus q will apply less force. So neither over here, not in the middle. So we say where it will be at infinity. Okay. No equilibrium position, you can kind of say. Let's move on to this one. Okay, is this visible? A particle of mass m. Tell me in the chats, is this visible? Is this visible, everyone? A particle of mass m carrying the charge minus q1. See. It is saying that a particle of mass m carrying the charge minus q1 is moving around plus q2. It says that we have got a particle that is, we say, sir, plus q2 over here. Okay. There is one more particle that is minus q1, which is revolving around this particle. Okay. Which is revolving around this particle. Let's suppose this distance is r. So it is basically moving in the circle. It is basically moving in the circle. It is moving in the circle. Okay. Find the time period. We are supposed to find the time period in this case. Sir, what does time period mean? In how much time this particle will cover one cycle? Let's suppose this minus q left from this point and then moving and covered one cycle. So how much time it took in covering one cycle, that's called the time period. That's called the time period. So we have to find the value of time period in this case. We have to find the value of time period in this case. Everybody, give it a shot at least. See, guys, don't you think that this minus q charge is performing the circular motion? Don't you think that this minus q charge is performing the circular motion? So whenever the minus q charge, whenever any charge performs circular motion, we say, sir, centripetal force will act on it. Okay. Centripetal force will act on it. And my dear friends, if centripetal force will act on it, listen to me very carefully. Sir, here are two charges. They are applying electrostatic force on each other also, sir. Electrostatic force will be also there. Sir, because charge 1, charge 2. And because of the circular motion, centripetal force will be there. And because of the charges, we say, sir, electrostatic force will be there. Always remember these two are equal. Always remember these two are equal. Okay. Always remember these two are equal. Okay. So we say centripetal force is equal to the electrostatic force. Now let's suppose if I say mass of this is given as m. Okay. And velocity is, let's suppose, v. It is moving with a velocity v. And I'm supposed to calculate the time period. First of all, sir, we say this centripetal force will be equal to mv square divided by r. Or you can also call the centripetal force is equal to mr omega square. One and the same thing, because v is equal to r omega. Either you say centripetal force is equal to this, or you say centripetal force is equal to this. Okay. So let me write this particular formula. Mr omega square is equal to, sir, what is electrostatic force? So that will be K Q1 Q2, that is Q1 Q2 divided by distance between them, that is R square. Okay. Now guys, listen to me very carefully. Take this M and multiply over here and take this R, multiply it over here. So can I say in this case, sir, omega square will be, sir, K Q1 Q2 divided by, we say M R cube. We say M R cube. Omega square is equal to K Q1 Q2 by M R cube. Okay. Now, listen to me very, very carefully. Listen to me very, very carefully. Sir, when it comes to the omega, we can say, sir, omega is nothing but 2 pi divided by t. We can say omega is, everybody knows it, okay? Omega is 2 pi f or omega we can write 2 pi divided by t also, okay, is equal to, and take this square over here, okay, it will become root, so it is under root of, we say sir, k q1 q2 divided by m r cube, okay. So can I say, sir, finally time period over here will come out to be, that is 2 pi, then we say under root of mr cube divided by k q1 and q2. Simply, this will be the time period in this particular case. Okay, this will be the time period in this particular case. Is that clear? Is that clear? Let me know in the chats. Is that clear? Simply, whenever you have to find this time period and all, so what you do is that you say, sir, centripetal, this charge is performing the circular motion, so centripetal force will act for sure. Okay, and there is electrostatic force also, make them equal, balance them, and you will get the answer. You will get the value of time period. Okay, cool. Let's move on to the next one. Okay, this one. Two small spheres, each having a charge plus q, are suspended by insulating threads of length L from a hook. The arrangement is taken to a space where there is no gravitational effect. Then the angle between the two threads and the tension in each case will be. Okay. Now see. Guys, it is saying that, let's suppose in the last class we discussed one concept. What is that? We say if we have got this thread and we are connecting a charge over here, if we have got this thread, we are connecting another charge over here. This is Q, this is Q. So we said, sir, they will remain in the equilibrium position, something like this. And what was the force acting in the downward direction? That is mg. In this case also, this is, sir, mg. Okay. And in this direction, we say, sir, electrostatic force were acting. In this case, sir, tension was acting. Okay. Yes. Now, what if I say if mg is equal to 0, this gravity becomes 0. There is no gravity. There is no force which is acting on this ball in the downward direction. If downward force is 0, what will happen? Sir, it will keep on elongating something like this, and it will go something like this. Okay. So we say then in that case, if we make this force 0, there is no gravity. We are taking it to the space where there is no gravity. Can we say this will something like, so they will elongate and it will be something like this. So I'll make it over here. So this will be charge Q and this will be, sir, charge, let's suppose Q. Okay. And if this length is L, means this length of this thread is L. That is given as L. Okay. And in this case, sir, now which forces will act? Sir, tension, thread is there, so tension will be there. And two charges are there, so electrostatic force will be there. It is saying. Now you tell me, two forces are something like this. Can you tell me what is the force? What will be the value of tension? Sir, now they are in equilibrium, something like this. So we say tension will be equal to the electrostatic force. So tension in this case will be equal to the electrostatic force. And my dear friends, what is the value of electrostatic force? You say, sir, K, Q1, that is Q, Q2, that is Q, divided by distance between the two charges. How much is that? That is L plus L, that is 2L. So we say 2L whole square. So I say this is K, Q square upon, we say 4L square. Hey, is this clear? Is this clear? This is what the questioner is saying. It is saying that if we place these two charges on the earth, so then the structure would be something like this. Gravitational force is over here. But if you take them to the space where there is no gravity, then they will behave something like this. In that case, tension will be equal to KQ square divided by 4L square. Okay. Okay. Let's move on to the next one. See, two small conducting spheres, each of mass, are suspended from a same point. Okay. We are given two small spheres over here. This one and this one. Okay. We are given two small spheres over here. This one and this one. This one and this one. And my dear friends, in this particular case, it is saying that they are given equal and similar charges. So Q charge to this one, Q charge to this one. Okay. Until the strings are equally inclined. So it is saying that this angle is given as 45 degrees. Strings are equally inclined at 45 degrees with the vertical, okay? The charge on each sphere is, we are supposed to find the charge on each sphere. Did I show you this question in the last class? I want you guys to tell me in this case. Guys, did I show you this pattern of question in the last class? I told you over there, we calculated tension, we calculated theta, we calculated charge, we calculated the distance or the separation between the two. Tell me guys, how to solve this problem. We are supposed to find the value of Q. Hey guys, I told you in the last class, if ever you get some sort of question, something like this, what is the first thing you guys are supposed to do? You'll basically balance the forces. Sir, what is the force which is acting in the downward direction? That is mg. So this will be, sir, tension T. And this will be, sir, electrostatic force. Okay. And towards left, listen to me, if this is T, can I say, sir, this is theta? This will be T cos of theta. And this will be T sine of theta. Yes, sir. Now, if the charge is in the equilibrium, I told you this force is equal to this force. I told you T sine of theta will be equal to electrostatic force, that is K Q square divided by distance between them is x square. Okay. And this force T cos theta, upward force, is equal to the downward force, that is mg. So if you ever get some sort of question, something like this, what is the first thing you are supposed to do? Draw all the forces acting on the body. Then balance those forces because the body is in the equilibrium. Upward force is equal to downward force. This left force is equal to right force. Okay. Now divide these two equations. Okay. T sine theta by T cos theta. Can I write it something like this? Sir, it will be tan of theta. Tan theta is equal to K Q square divided by x square into mg. Okay. Now in this particular case, we are supposed to find the value of Q. Take it over there. So this will be x square mg. Then we have tan of theta is equal to, and we have Q square into K. Divide the K over here. This is the value of Q square. And finally, Q will come out to be, we say, sir, x square, this mg, then we say tan theta, and divided by, we say, sir, K, and then we say 1 by 2. Now, this is how you find the value of Q in this particular case. In the last class, I have explained it. Tell me one thing. Sir, what is x square? X square means separation between the two. Sir, by a non-kind of length, this, incline. Just a second. Okay. Two small conducting spheres, each of mass this, are suspended by a same point. Their angle of 45 degrees. Yes. Yes. See. In this case, what is the one thing that you guys are supposed to do? Guys, see. This is the formula that you will be using. One more point I just want to add over here. Let's suppose if in some question this x is not given. Let's suppose if in, now you can put the values. Let's suppose if in some question x is not given. What is the case that you will be doing in that particular question? Listen to me very carefully. See, guys, this is x over here. Between the two charges, this is given as x. Listen to me very carefully. I say, can I say in this particular case, sir, this will be x by 2. This will be x by 2 and this will be x by 2. And length of the string is given as L. Listen to me very carefully. This is, sir, x by 2 and this is given as L. Now, can you tell me in this particular case, what is the value of, listen to me very carefully, what is the value of, sir, sine of theta? Sine theta is, we say, simply perpendicular upon hypotenuse. I can say over here, sine theta is perpendicular. We say, sir, perpendicular is, if this is theta, we say, sir, perpendicular is this x by 2, x divided by 2L. L will be the length. Okay. Now, my dear friends, if this theta is over here given, listen to me very carefully. Put the value of theta over here. We say, sir, 45 degrees. Put it over here, sine 45. So multiply 2 over here. X will be equal to, we say, sine of theta into, we say, sir, 2L. Now, see, sir, length of the string is given. If length is given, multiplied by 2 and put the value of sine theta. Put the value of sine theta. Okay. You will get the value of X. Now come over here. So once you calculate, it is in that question in which X is not mentioned, Now put the value of X over here. Mass of the ball is given. Acceleration due to gravity is given. Tan of this is over here, tan 45. Then value of K and 9 into 10 raised power 9. And solve it, you will get the answer. Okay. This is your homework. Put the values and you will get the answer in this case. I guess in this case, it is 1.4 or 1.6, something like that. Okay. Is this clear? Is this clear, guys? I'll not waste the time in calculations over here that you guys do from your end. Let's move on to the next one. No, this is not tough category question. Just you have to understand the approach of the question. That's it. Now we have got find the position where net electric field is 0. See. In this question, what is given is that we are given, sir, 2 microcoulomb charge and we are given 8 microcoulomb charge over here. Distance between them is 12. Distance between them is, we say, sir, 12. In this case, you have to tell me find the position where net electric field is 0. Guys, listen. If you are asked to find the position where net force is 0, or you are asked to find the position where net electric field is 0, and charges are similar, positive, we say in that case, we use one formula, that is under root of R upon under root of N plus 1. This formula is valid over here also. And if I say for opposite charges, I say, sir, X is equal to R upon, we say, under root of N minus 1. For opposite charges, we say X is equal to R upon under root of N minus 1. Keep these two formulas in your mind. Sir, find the position where net force or net electric field is 0 if the charges are similar. Positive. We use this formula. If I say this is minus 2Q plus 8Q, so we say we'll use this formula. Now in this case, tell me, sir, we can use over here X is equal to, what is the value of R? R is, we say, sir, 12 upon, sir, root of N. What is the value of N over here? How to find N? Sir, N is equal to this charge 8 divided by this charge, that is, we say, sir, 4. So we say, sir, this is root 4 plus 1. So this is 12 divided, root 4 is 2 plus 1 is 3. Is that clear? Is that clear? So at 4 centimeter, so we say at 4 centimeter, X is equal to 4 centimeter, we say net electric field will be 0. Net electric field will be 0. This is the simple logic that we guys are supposed to apply over here in order to solve this question. This is the simple logic. Guys, like this session if you have not liked the session, because that is mandatory. Everybody out there. Okay, make the like count. I want you guys to increase it and let's make it 1K. Let's make it 1K. Okay. Now see this question. Find the net electric field at the center. 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 You have got a triangle over here. Plus Q charge, and plus Q charge. See. We have studied if we have got a charge, let's suppose plus q. Sir, at r distance, it creates the electric field E is equal to kq by r square. This is what we have studied. In this particular case, we say, sir, this is the charge. This charge will create the electric field at this point, something like this. Let's suppose that is E. Sir, this is positive charge. This positive charge will create the electric field at this point, that is E. And this electric field, if the charge is positive, we say electric field is away from the charge. And if the charge is negative, we say electric field is towards the charge. So we say, my dear friends, this charge will exactly apply the force, will create the electric field, something like this. This is also E. Okay. Now, guys, between the two, these two, we say angle will be 120 degrees. Tell me one thing. If the angle between the two vectors is 120 degrees, have we studied, sir, resultant of this one and this one will be something like this? And if this is E and this is E, so we say this resultant in that case, this resultant in that case will be also, sir, E. Now, upward vector is E, downward vector is E. Can I say this will cancel with this one? So net in this case will come out to be 0. Yes, net in this case will come out to be 0. Net in this case will come out to be 0. Okay, as simple as that, as simple as that. So guys, let's suppose if I have given you this question, let's suppose this is, sir, plus Q, this is, sir, plus Q, this is, sir, plus Q, and this is, sir, plus Q. What is the net electric field at the center? You say simply, sir, 0. Either you say net force at the center is 0, that's okay. Or you say net electric field at the center is 0, that's also okay. Because if the charges are identical or similar and present at every corner, then we say net force at the center is 0. Then we say net force at the center is 0. Okay. Now. This question, very important. This was asked in the JEE previously. And yesterday also I have shown you one pattern of question on this. It is asking find the net electric field at the origin. This is the origin. At origin, you guys are supposed to find the net electric field. At origin, you guys are supposed to find the net electric field. Tell me. Guys, if we have to find the net electric field at the origin, listen to me very carefully. Sir, at this point, this charge will create electric field. At this point, this charge will also create the electric field. At this point, this charge will also create the electric field. So all of these charges will create the electric field at this point. So can I say electric field because of the first charge, it will be kq divided by, how much is the distance from origin? That is 1 square. That is 1 only. 1 square is, we say, sir, 1 only. Okay. 1 square is, we say, sir, 1 only. Then we say plus. Electric field because of this charge at the origin, you can simply say, sir, that is kq divided by this 2 square. That is 2 square is, we say, sir, 4 plus. Electric field because of this charge at the origin, you can simply say, sir, that is kq divided by 4 square, that is 16. Electric field because of this charge at the origin, that is kq divided by 8 into 8, that is 64, plus so on. Now, what is the one thing that we can take common over here? That is, sir, kq. And what remains? 1 plus 1 by 4 plus 1 by 16 plus 1 by 64 plus so on. Okay, so on. Now, guys, sir, this is what we call the geometric progression. And how do we find the sum of this? We have studied, sir, sum is a upon 1 minus r. A means the first term. First term here is 1. And r is common ratio. How to find common ratio? Take any term over here. Let's suppose I'm taking 1 by 16. Divide it with the term which comes before it. That is 1 by 4. So 4 ones, 4, 4. So it is 1 by 4. Now put it in this one. So sum will come out to be 1. A is 1 upon 1 minus. R came out to be 1 by 4. How to find the common ratio? Take any term, divide it with the term which comes before it. Okay. So this will be 4 into 1 is 4. 4 minus 1 is 3. 3 by 4. So it will be 4 by 3. So sum of all of this is coming out to be, we say what? 4 by 3. So answer in this case is KQ 4 by 3. So this will be the net electric field. Or further also you can simplify it. You can put, see, this is 4 by 3 q. Instead of k, you can write 1 by 4 pi epsilon naught. This 4 and 4 you can cancel. So you can write q by 3 pi epsilon naught. This is the final answer. Is this clear? Is this clear? Is this clear? Is this clear? Tell me, guys. Make sure you like the session, guys, if you have not liked it. Let's move on to the next one. Okay. You have got this particular question in this particular case. Okay. Now, in this case, you guys are supposed to tell me, find the horizontal and vertical component of the electric field, Horizontal and vertical component of the electric field. See, you have got a cord over here. On this cord, we say charge Q is present. You have got a cord over here. On this cord, charge Q is present. And you guys are supposed to tell me how much is the net electric field at the center. You guys are supposed to tell me how much is the net electric field at the center. See, sir, we have studied because of the cord, the electric field at this point will be, sir, that is under root of 2k lambda divided by, we say, sir, if this is R, so this will be divided by R. Because yesterday, I have told you, if you have got a cord, because of the cord, electric field is root 2k lambda by R. Yes. Now, guys, listen to me very carefully. I'll make you understand. Have you studied, sir, if we have got force F, we say, sir, in this case, angle is 90, resultant is root 2 of F. Okay. I can say it something like this also. If you have got a resultant root 2F and means its horizontal component, vertical component will be F, horizontal will be F. I can call it something like this also. Same is the case over here. We say if we have got F vector, that is under root of k lambda by R. See, here you have F, here you have k lambda by R. Here you have root 2F, here you have root 2k lambda by R. Can I say, sir, its horizontal component will be k lambda by R, and its vertical component will be k lambda by R. Then only its resultant will be root 2k lambda by R. So its horizontal component is what? K lambda by R. Its vertical component is what? K lambda by R. This is what I wanted to exactly show over here. This is what I wanted to teach exactly over here. Okay. Guys, are you loving this session? I am being to the point. Okay. The amount of information you need, I am giving you that only, that much only. Okay. Are you loving the session? Tell me in the chats. Great. Okay. Now, find the net electric field at the center. You have got this semicircular ring. Half of this semicircle contains, we say, positive charge, and half of this is containing negative charge. Basically, you can divide this in two chords. Okay. So we say, let's suppose this is radius R over here. Okay. Now see, listen to me very carefully. Sir, we have studied because of this cord, electric field at this point will be something like this. Okay. And this will be a root 2k lambda divided by R. Because of the cord, how much is the electric field? Root 2k lambda by R. Because we have divided this in two chords, this one and this one. Now this is the negatively charged cord. We say in case of negative charge, electric field is towards the charge. So this will also be but root 2k lambda by r. Why? Because it's a cord. Even if it is the positive charge on the cord or the negative charge, the electric field will be same, but the direction will be different. Now see, this one and this one. Can I say, sir, resultant in this case will be this, and this angle over here is 90 degrees. Sir, resultant is this. Guys, if you have force F, what is the resultant if angle is 90 degrees? Root 2F. If you have root 2k lambda by r, what is the resultant in this case? You say, sir, resultant in this case is under root of, then this force, we say, sir, that is root 2k lambda by r. So what is root 2 into root 2? That is 2k lambda divided by r. This is the answer. 2k lambda divided by r. I hope you got it. If it was x, then we would have said root 2x. Tell me in this case, what is the net electric field at the center? What is the net electric field at the center? Find the net electric field at the center. Tell me, guys, what is the net electric field at the center? Yes, guys, see, we can divide this into 4 chords. Okay? We can divide this into 4 chords. Now see, this chord contains positive charge. So because of this chord, electric field at center will be away from the chord. Now this chord also contains positive charge. Because of this chord, electric field at this point will be also away from the charge. Now this chord contains negative charge. So because of this chord, electric field will be towards the chord. This chord also contains negative charge. Because of this chord also, electric field will be towards the charge. We say, sir, this will cancel with this. This will cancel with this. So we say net electric field at the center is 0. Important question, this one. We are given an infinitely long charged wire. Okay. And there is a charge which is revolving around it, that is minus q. Infinitely long charged wire, positive charge is present on this wire. And a negative charge is basically revolving around it. It is having the minus q charge. And mass of this charge is m. And it is going with the velocity v. We are supposed to find the value of this velocity in this particular case. Come on, give it a try. Let me know the answer in this case. See, guys, I told you, whenever any particle is performing the circular motion, like this particle is performing the circular motion, we say, sir, centripetal force will act on it simply. Okay? And this rod has got positive charge. This has got negative charge. So this rod will be applying force on this charge. If this is positively charged, this is negative charge. Rod will attract this with electrostatic force. So we say that electrostatic force I'll write over here. Sir, centripetal force will be equal to the electrostatic force. Now I'll write, sir, this will be simply m v square divided by r. R is the distance at which the charge is placed. V is the velocity of the charge. M is the mass of the charge. Is equal to, sir, electrostatic force. Guys, see, if we say we have got electric field over here, and in this electric field you are placing a charge. So force on this is, sir, Q times of E. I hope you remember. Now see, sir, because of this infinitely charged rod, electric field will be present in this region. And in that electric field, this charge is present. So this charge will experience the force, how much? Q times of E. Q is the charge and E is the electric field due to the rod. Now see, can I write it something like this, sir? We say this is m v square divided by r is equal to Q into. Now, Electric field because of the rod, because of the infinitely long rod is how much? I have told you in the last class, electric field because of the infinitely long rod, that is 2k lambda divided by r. 2k lambda by r. Okay, I hope you know it. And electric field because of the semi-infinite rod is root 2k lambda by r. Okay, so I can further write it something like this over here. I can write it something like this over here. So this will be, this r and this r we can cancel. So this, take this m over here. So v square will be simply, so that is 2qk lambda divided by, we say, sir, this is m. So v is equal to under root of 2qk lambda divided by m. This is the velocity with which the charge will move exactly over here. And what is k? K is the charge per unit length. K is the charge per unit length. Okay. K is the charge per unit length. Next question. Find the flux through the cylinder. Find the flux through the cylinder. This charge is present at the mouth of the cylinder. This charge is present at the mouth of the cylinder. Can you tell me how much will be the flux? Guys, see, if I say this charge was inside this cylinder, then we use the simple Gauss law. What does that say? Flux through any closed surface. If the charge is present inside the closed surface, flux through any closed surface is Q divided by epsilon naught. Flux through any closed surface is Q divided by epsilon naught. But since the charge is not present over here, so let me do one thing. Charge is present, we say, at this mouth. What I want to do in this particular case is we will attach an imaginary one more cylinder over here. Let's suppose we are attaching one more cylinder over here. This is the cylinder that we have attached over here. Okay. Now tell me, sir, now this charge comes in the middle of the two cylinders. Now can we say, sir, this charge will behave like an enclosed charge? This charge will behave like it is present inside the surface. So we say now it is a closed surface for charge Q. Okay. Closed surface over here made by basically two cylinders. So can I say in this particular case, flux through closed surface. Listen to me very carefully. Flux through a closed surface means closed surface is made up of two cylinders. That will be flux through two cylinders. That is equal to, sir, how much Q divided by epsilon naught? Because we know flux through a closed surface is Q by epsilon naught. So this is the flux through two surfaces. Flux through one surface will be how much? You say, sir, flux through one surface, I'll directly write half of this one. Flux through one cylinder is 1 by 2 of Q by epsilon naught. And that is Q by 2 epsilon naught. Okay. Let's talk about this one. Can you tell me, find the flux through the sheet? Find the flux through the sheet. You guys are supposed to tell me what is the flux through the sheet. Find the flux through the sheet. Everybody. And the charge is placed at the corner of the sheet. The charge is placed at the corner of the sheet. Can you tell me how much is the flux? Guys, it is like, let me show you over here. It is like you have got this sheet. You are placing the charge at the corner. We say, sir, because of, like over here. We say, sir, because of this sheet, we say because of this charge, field lines will leave something like this. They cannot go and cross the sheet. These field lines cannot go and cross the sheet. If no field line is crossing the sheet, so we say in this case flux is 0. Because no field line is crossing the sheet. No field line is crossing the sheet. So if field line crosses the sheet, then only we say flux through that sheet will be Q by epsilon naught. If there is no field line which is crossing the sheet, we say in that case flux will be 0. Tell me what is the flux through this? Flux through the cube. Find the flux through the cube. Find the flux through the cube. Everybody out there, tell me what is the flux through the cube? What is the flux through the cube? I'm looking at the chat box. I want to know from everyone. Guys, like the session. I want everybody of you to like the session because that is mandatory. Tell me, guys. Tell me. See. In this case, we have placed the charge over here. Okay. We are supposed to find the flux through the cube. Okay. If the charge was inside the cube, then we would have said easily Q by epsilon naught. But the charge is present at this edge. How many more cubes we are supposed to add so that this charge comes in the center? We say add 3 more cubes. We say add 3 more cubes. So I can say 1 cube, another cube, and another cube. When you add 3 more cubes over here, charge will come. Then charge will become enclosed. So we say then charge will become enclosed. Now, my dear friends, we can simply say, sir, flux, then it becomes the closed surface. Flux through the closed surface will be then equal to flux through 4 cubes. Okay. That will be equal to Q divided by epsilon naught. That will be simply equal to Q by epsilon naught. So this is the flux through 4 cubes. Sir, flux through 1 cube will be how much? You say, sir, simply that is Q divided by 4 epsilon naught. Or 1 by 4th of Q by epsilon naught. 1 by 4th of Q by epsilon naught. Come over here. I say if the flux through curved surface, if the flux through curved surface is phi naught, then find flux through one plane surface. Then find flux through one plane surface. If the flux through curved surface is phi naught. See, guys, we have got the cylinder over here. Let's suppose I have got a cylinder over here. Okay, this is a bottle. We say flux through, listen to me very carefully. If this is a bottle, this bottle is made up of curved part, plane part, one more plane part, 2 plane surfaces and 1 curved surface. I am saying that flux through this curved surface is how much? That is phi naught. It is given as phi naught. What will be the flux through one plane surface? What will be the flux through one plane surface? That's what I'm supposed to calculate. What will be the flux through one plane surface? Okay. See, guys, see. I'll tell you. Sir, if we write over here, sir, this cylinder means this cylinder. Listen to me very carefully. This cylinder. Okay. Or this cylinder is a closed surface because the charge is present inside. So we say this flux through this closed surface will be. Sir, this cylinder is made up of 3 parts. That will be flux through curved surface, flux through curved surface, plus we say, sir, flux through two plane surfaces. Flux through two plane surfaces. Okay. Flux through curved surface and flux through two plane surfaces. And that will be how much? Q divided by epsilon naught. Yes, sir. Why? Because we know flux through a closed surface is Q by epsilon naught. And let me write it over here. So this will be simply, sir, Q divided by epsilon naught. Flux through closed surface will be Q by epsilon naught. Now is equal to, we say, sir, flux through curved part. Flux through curved part is given as phi naught. So let me place it over here. This is phi naught. Plus, we say, sir, flux through two plane surfaces. Now take it over there. So I write flux through two plane surfaces will be simply, that is Q divided by epsilon naught minus, we say, sir, phi naught. And then we write flux through one plane surfaces. Guys, see, because of the two, this much is flux. Because of one, how much will be the flux? Half of this, that will be half of Q divided by epsilon naught minus, we say, sir, phi naught. This will be the flux in that case. This will be the flux in that case. This is a next level problem, very important. I have already shown you another problem of the same pattern in the last class, if you remember. Over there, instead of cylinder, I took the hemispherical bowl. I hope you remember. Okay. This was asked in JEE 2010. JEE 2010. Tell me, in this case, the question is, we have got a cube over here, okay? Inside the cube, inside the cube, I'm placing a charge. Outside the cube, I have placed a charge. Inside the cube, I have placed a charge. Outside the cube, I have placed a charge. Now, because of this charge, we say, sir, these are the field lines which will cross this surface. Because of this charge, these are the field lines which will cross this surface. Okay, half of the answer I told you. Find the flux through ABCD part. You guys are supposed to tell me the flux through this surface only. How much is the flux through this surface? What is the net flux through the ABCD surface? Can you tell me in this case? How much is the net flux through this ABCD surface? Tell me. I say simply, sir, flux through ABCD will be 0. Why? Because I'm saying that, sir, because of this charge, field lines will be there and that will cross this surface. Because of this charge also, field lines will cross this surface. So the number of field lines because of this charge is going in is equal to the number of field lines which are coming out. So we say net flux in that case will be 0. Is that clear? Is that clear? Okay. JEE Advanced 2014. This is the NEET level question. Okay. I will show you in just one. Its answer is in one line. Okay. And this question was actually asked in JEE Advanced 2014. It's not difficult at all. You will kill it. Just give it a shot. You have to compare. I'll write over here. Compare the electric field. Compare the electric field in all the three cases. Like you have to find the electric field because of this at this point, because of this at this point, because of this at this point. This is very easy, extremely easy. Give it a shot. Give it a shot. Once. See, I will show you. Let me show you. Let's suppose we have got a sapphire over here. Okay. And on this sapphire, the charge is, listen to me very carefully. On the sapphire, the charge is Q. And the radius of the sapphire is R by 2. This is the radius. And I am asking you to find the electric field at P point, which is at R distance, means outside. Means outside the sapphire. This R. So means in this case, small r is this. Tell me one thing. Can I say, sir, electric field because of a sapphire? Listen to me very carefully. Electric field because of a sapphire, and this is a solid sapphire, given it a solid sapphire. Because of a solid sapphire, outside is KQ divided by R square. R means the distance in which you are finding. In this case, R is equal to this R. R is equal to capital R. So I can simply write this is for outside point. Outside point. Okay. So I can say, sir, this electric field will be KQ divided by, what is the value of R in this case? That is capital R square. That is capital R square. Okay. Now, let's come over here. Let's call this as E1, E1. Let's talk about E2. Let's talk about E2. Can I say, sir, in this sphere, we have to find the electric field at point P, which is on the surface of the sphere. Radius of the sphere is also R. So we use the surface formula. What is that? E2 is equal to, sir, KQ divided by. On the surface, what is the formula? KQ divided by capital R square. So that is KQ divided by capital R square. If you were present in the last class, then you would have seen this. Okay, so we say in this case, sir, what is the charge? That is 2Q. So I say in this case, E2 is equal to, sir, 2 times of KQ. 2 times of KQ divided by R square. Why? Because the charge on the sphere is 2Q. That's why I mentioned 2Q. Okay, so this is the surface point. Let's talk about the third one. Let's talk about the third one. Sir, I'll write over here E3. E3. Tell me one thing. Tell me one thing. Guys, this is a sphere that we have over here. Sir, we have to find the electric field at this point P, which lies inside the sphere. Which lies inside the sphere. Radius of this sphere is... Oh, shit. क्या कहना? It's good, right? Good. Let's get. No, मैं ये आज चुक टाइम लगता है. मैं तो तामक बतले में बतू है. ठीक. Hello. What's up? How are you? What's up, people?
Yes, they already know it's me, huh? Nice. Guys, one thing, I have posted the schedule, right? I hope you have seen the video which I posted in the morning. In that video, I have given the complete schedule till 20th of April. Because a lot of students were like telling what are the upcoming sessions which you have planned for week 2, week 3, etc., etc. How come syllabus is getting completed? I have given the entire schedule. Please check that video afterwards, okay? Please check that video. You'll get the idea like which marathon is on which date and till what date your syllabus is getting completed. Perfect? Just check that video after this. And one thing I'm telling you, right, on behalf of complete team, after following these marathons and the question practice, you are not supposed to do anything extra on your own. No need to go for any study material now. No need to solve anything. Just your marathon plus the question practice which your teachers are doing after the marathons, that is more than sufficient for you. Okay? And your yesterday's PDF, I'll send in the evening. Okay? Perfect? Just be relaxed. You're not supposed to do anything extra. Nothing extra. Just follow these sessions. It is more than sufficient.
Yes, guys. Okay.
Someone is saying blue and red. It's not blue red. It's blue maroon. I should tell you. You guys carry on. Take it.
मैं मानता हूँ ये क्या कर मीटिंग उस पंग मत लियो. Now see, let's talk about this one. E3. Let's talk about E3. Electric field due to this sphere at this point P. This point P lies inside the sphere. Listen to me very carefully. This point P lies inside the sphere. Okay? This point P lies inside the sphere. Now see. So we say for inside, what is the formula? We know, sir, for inside, we say, sir, that is KQ divided by R cube into R. This is what I have told you in the last class. This is for inside point. Inside point. Means if you have to find the electric field because of a solid sphere inside, this is the formula which we actually use. So we say, sir, this E3 will be simply, that is K. What is the value of Q over here? The Q charge on this sphere is 4Q. So I can write over here, this is 4Q divided by, what is the value of R? R means the radius of the sphere. Radius of the sphere is 2R. So I can simply say, sir, this is 2R. We say whole cube. And then the small r. What is the value of this small r? Means at which distance you are finding right now. So we say, sir, that is R, capital R over here. So we say value of small r is capital R. Okay. Now guys, can I solve it further over here? We say, sir, this will be 4KQ upon This is 2 cube is 8 r cube and this r. Okay. Now you can cancel with this over here. So we say this will be 4 ones, 4 twos. So finally, in this case, it will be k cube divided by 2r square. So this is E3. This is E3. Now you have to compare E3, you have to compare E2, and you have to compare E1. Clearly, you can say over here, this is k cube by r square. This is 2k cube by r square. Clearly, you can say, sir, E2 is greater than, come over here. This is k cube divided by 2r square. So we say E2 is greater than, E1 is greater than E3. Is this the correct order? Tell me in the chats, everybody out there. Guys. Is this clear? Is this clear? Is this clear? This was a solid. Solid sphere means non-conducting. Solid sphere means non-conducting. Okay. Simply you were supposed to find the electric field. In this case, the point is outside. In this case, the point is surface. In this case, the point is inside. Then compare the 3 electric fields, and this was asked in JEE Advanced 2014. Great, 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 great. Let's come over here. Find the value of sigma. We have got a charged conducting plate. Charged conducting plate. And you have got a charge over here. You have a thread. Then you have a thread attached over here, the charge, and this mass is m. And in this particular case, you guys are supposed to tell me the value of sigma. You guys are supposed to tell me the value of sigma in this particular case. Okay. Value of sigma. Sigma means charge per unit area. Charge per unit area. Surface charge density or charge per unit area. Surface charge density. Tell me, guys. You are supposed to tell me what is the value of sigma over here. Guys, like this session if you have not liked as soon as possible. That's mandatory. That's mandatory, okay? See. In order to solve this question, we have a sheet and then his thread is attached to the sheet and the charge over here. We say, sir, this charge is at rest. It is in the equilibrium. What is the force which is acting on this charge in the downward direction? That is mg. Okay. And we say over here we have got tension T. Clear? Now, my dear friends, this sheet is charged sheet. It is applying force on this. So that force will be something like this. We say, sir, that is electrostatic force. That is electrostatic force. Now, guys, tell me one thing. This T we can resolve in 2 components. If this is T, we say, sir, this will be T cos of theta. Because this is theta. This is theta. This is theta. And this will be, sir, T sine of theta. Can I say over here, my dear friends, sir, if the charge is in the equilibrium, this force is equal to this force is equal to this force. So I can say T sine of theta is equal to, we say simply that is electrostatic force. And this electrostatic force, I told you it is Q times of E. Q is the charge, E is the electric field because of the charged sheet. Sigma by 2 epsilon naught. Okay. And then you have T cos of theta is equal to, in this particular case, that is we say, sir, that is we say mg. Divide this equation with this equation. So we say T sine theta by cos theta, it is we say tan of theta is equal to, we say this will be QE divided by, we say, sir, mg. QE divided by mg. Now, guys, my dear friends, can I say, sir, take this mg over here? So we say this electric field will come out to be, that is mg divided by q into tan of theta. Okay. Now, instead of this electric field, we know, sir, electric field because of this charged sheet. Okay. That is how much? We say, sir, that is sigma divided by 2 epsilon naught. Okay. Sigma by 2 epsilon naught because of the conducting plate over here, sigma divided by 2 epsilon naught. Okay. Is that clear? It was sigma by epsilon naught, I guess. Sigma by epsilon naught. Sigma by epsilon naught, huh? Because of the conducting plate, sigma by epsilon naught. Guys, tell me. I forgot. Yes, okay. So we say this will be simply that is mg divided by q, and then we say tan of theta. Now take it over there. So sigma will come out to be that is mg divided by q, and this epsilon naught, then we say tan of theta. So this will be the value of sigma in this particular. Okay. Two epsilon naught. Okay. I forgot. So take the 2 over here also. Done. Okay. So this was basically the sigma we were supposed to calculate. This we were having the sheet over here. I'll give you. We were having the sheet, and attach a thread to the sheet. There is a charge. Okay. Now we are supposed to find if the charge is in the equilibrium. The charge is in the equilibrium. I'll write over here the charge Q is in equilibrium. Okay. And we are supposed to find the value of sigma in this case. We are supposed to find the value of sigma in this case. Okay. Now let's talk about this one. Find the electric dipole moment. Now we have to find the electric dipole moment over here. We have to find the electric dipole moment over here. Okay. Sorry. Back. Okay. Now see. Take a look over here. Find the electric dipole moment. See, you have got this square over here. At this corner, you have placed PQ. Let me make it over here once again. Let me make this over here once again. Let me make it over here once again. Yes. Now see, at this corner we have placed 3q charge. At this corner we have placed minus q charge plus 2q charge. At this corner we have placed 4q charge, minus 4q charge. We are supposed to find the net dipole moment in this particular case. Listen to me very carefully. My dear friends, first of all, we have to see how many dipoles are being created over here. Do one thing. Sir, this is minus q. Can we just do one thing? This is plus 3q. I can write plus q over here, plus 2q over here. Can I do something like this? Yes. Sir, plus q and plus 2q is plus 3q. Similarly, over here, this is minus 4q. Can I write it something like this? Sir, this is minus 2q and this is minus 2q. Minus 2q and minus 2q is once again, we say what? That is minus 4q. Now tell me one thing, guys. In this particular case, we say, sir, equal and opposite charges. Don't you think that this is minus 2q and plus 2q? Don't you think that this is, we say, sir, dipole moment in this particular case? So dipole moment will be from negative to positive and charge is 2q. So we say dipole moment. This is basically one dipole formed over here. And this is another dipole formed over here. Equal and opposite charges. And this is one more dipole formed over here. Total number of dipoles formed over here are 3. Okay. So we can say this is 2p. Between this 2q and this, we have one more dipole, that is also, we say 2p. Between this and this, we say we have one more dipole, that is also, we say, sir, p. If the charge is q, we say dipole moment is p. This has got dipole moment 2p because charge is 2q. Now see, Can I make it over here? Sir, this dipole moment, that is 2p, I'll make it over here. Sir, this dipole moment, I'll make it somewhere around over here, that is 2p. And this dipole moment, I'll make it over here, that is, we say, sir, p. Okay. Now tell me one thing, my dear friends. What is that? What is that? If this is p, this is 2p and this is 2p. The resultant of this 2p and p will be p in the downward direction. This is p, and in the forward direction, this is 2p. Can I say, sir, net of these two will be something like this? This will be net p net. And this p net will be simply, this p net will be simply, this p net will be simply. Listen, this will be square of this, that is 2p whole square, plus square of this, that is p square. So how much this will come out to be? 2p whole square is 4p square, plus we say, sir, p square. And 4p square plus p square is 5p square. So finally it will come out to be root 5p. So net dipole moment of this entire figure is how much? Root 2p. Sorry, root 5p. Root 5p. Is this clear, guys? Tell me in the chats. Is this clear? Everybody out there, is this clear? Is this crystalline clear, guys? Is this crystalline clear? Okay. Let's come over here. Now see, we have got this figure somewhere around over here. We are supposed to find the net dipole moment. Net dipole moment. In this case also, we are supposed to find the net dipole moment. See, guys, we have got this plus q charge and we have got this minus q charge over here. Listen to me very carefully. Sir, is this a dipole? First of all, let's talk about that. Is this a dipole? We say yes, because we have got equal and opposite charges. Now the question is, equal and opposite charges are separated by some distance. Okay. Now the question is, sir, if we have got a plus q charge over here, if we have got a plus q charge over here, minus q charge over here, we say, sir, they are separated by some distance. We call this dipole. But how can we write the dipole moment of this? See, we say in this case, you consider the charge of the upper ring at its center of mass, Its center of mass is at 2r by pi. 2r, if this is r is the radius, 2r divided by pi. Its center of mass is at 2r by pi, and we say this will be also at 2r divided by pi. So the charge of this ring will be also at 2r divided by pi. Now guys, tell me, this is 2r by pi, 2r by pi. How much is the distance? This is negative charge over here. This is positive charge over here. So can I say in this particular case, dipole moment is, sir, that is magnitude of charge, that will be q, multiplied by distance between them. Sir, that is 2r by pi plus 2r by pi, that is 4r divided by pi. 4r divided by pi. Is this clear, guys? Is this clear? 4r by pi. Let's move on to the next one. Okay, this question. We say you have got over here a square. You have got a square. Okay. And then you have a dipole placed over here. Okay. Dipole moment is P. This angle is given as 45 degree and the side of this is L. I can clearly say that this diagonal will be under root of 2L. Now this is the point A, this is the point B. We are supposed to find the electric field at point A and B. If you have got a dipole over here, because of the dipole, you are supposed to find the electric field at point A and electric field at point B. Electric field at point A and electric field at point B. Okay. Now listen carefully, my dear friends. Listen carefully, my dear friends. I'll be sending you the yesterday's notes and today's notes also in the Telegram. Don't worry about that. You can join my Telegram, that is t.me/Yawar Manzoor. This is my Telegram. Okay, you can join this one. Now see, take a look over here. Guys, find the electric field at A and B. Find the electric field at A and B. Tell me one thing. Sir, this is the point which is what we call the arbitrary point. And this point is, we say, the actual point for this dipole. Let's talk about the electric field at point A. In the last class, I told you, sir, if this is theta, at this point, electric field will be Kp divided by x cube. X is this distance. Then we say under root of 1 plus 3 cos square of theta. Theta is this distance. Theta is this angle. Now we say, sir, this is Kp divided by, what is the value of x in this case? That is under root of 2L. Under root of 2L, its whole cube. Okay. And then we say under root of 1 plus 3 cos square of theta. We say, sir, cos square of, what is the angle over here? That is 45. That is 45. Okay. Now, my dear friends, in this particular case, I can simply say, sir, this will be simply, what is that? That is, we say, sir, this is Kp upon, listen to me very carefully. This is root 2 whole cube. I can write it something like this, root 2 whole cube multiplied by L cube, Yes, there is no problem in that. And then we say this over here. This is 1 plus 3 cos 45, 1 by root 2. It's square, 1 by 2. So 3 by 2. 2 into 1 is 2. 2 plus 3 is 5. So 5 divided by, we say, sir, 5 divided by, we say, sir, 2. 5 divided by 2. If you solve this, it will be 5 by 2. Now listen to me very carefully. Sir, this is root 2 whole cube. Means this is root 2 into root 2 into root 2 into root 2. 3 root 2. 3 times root 2. And you have got one more root 2 into one more root 2. Sir, root 2 into root 2 is 2 multiplied by root 2 into root 2 is 2. So this is 4. Okay, this is class LKG. Okay, I am showing you over here. So this is 4. So instead of this root 2 and this we can write 4. So I can simply say this will be Kp divided by L cube. Then we say root 5 divided by 4. And this will be the electric field at A. This will be the electric field at A at this point. I hope this is clear. Similarly, if we want to find the electric field at B, let's find the electric field at B. Sir, this B is the actual point. So if we have to find the electric field at the actual point, we know, sir, electric field on the axis is, we say, sir, twice Kp divided by x cube. So we say that will be twice Kp. What is the value of x over here? That is L cube. So we say, sir, this is L cube. I hope this is clear. Is this crystalline clear? Let me know in the chats. Everybody out there. Okay, this was asked in NEET 2022. Okay, what is the ratio of the electric field at the point on the axis? We are supposed to find the electric field on the axis divided by at equidistant point divided by perpendicular bisector point. Okay. Sir, this is nothing but 2 Kp divided by x cube divided by this is Kp by x cube. 2:1. Done. Is that clear? Okay, this one. See. You have got the triangle over here. At the corners of the triangle, you have got the charges, okay? Now, distance between the charges is, we say, A. Now, what we are doing is that we are shrinking this. We are shrinking this triangle over here. What does shrinking of triangle mean? We are making the distance from A to A by 2. We are getting these charges closed. Let's suppose they are 1, 2, 3. We are bringing them close. So means on bringing the charges close, find the work done by external agent. We have to find how much work we need to do in order to bring the charges close at what distance? A by 2 distance. Sir, whenever we have to find the work done, we say work done is simply change in potential energy. Can we say it something like this? Yes. Now we say, sir, work done is equal to final potential energy minus initial potential energy. Sir, question is, what is final potential energy over here? See, Finally, the system is something like this. So what is final potential energy? We say, sir, that is potential energy of this system. How to find the potential energy of the system? Sir, that will be KQ between these two pairs plus these two pairs plus these two pairs. In the last class, I told you. How do we find the potential energy of this system? See, we say, sir, that is K. If I say between these two charges, what is the potential energy? KQ square, KQ1, Q2, Q square divided by, sir, A by 2. Divided by A by 2. And this is how many times? How many pairs are? 1, 2, and 3. So this will be 3 times. So now we can 3 into 2 is 6KQ square by A. Now come over here. What is the initial potential energy? Sir, initial potential energy in this case is, we say, sir, that will be 3 times of KQ square divided by A. Why? Because between the two charges, potential energy is KQ square by A. Between these two also same. Between these two also same. That's why 3 times. Now tell me, work done is final potential energy is how much? 6KQ square divided by A minus initial over here is, we say 3KQ square divided by A. So I can say this will be 3 times of KQ square divided by A. 3KQ square divided by A. Is this clear? Take a look at this question. Take a look at this question, guys. Solve it. Take a look at this question. I want every one of you to solve this question. And do like the session, guys, if you have not liked the session yet. Tell me, what is the option that is correct over here? Option 4? Yes, option 4 is correct in this case. Why? See, in this question, what does it actually say? What does it actually say? See. We say, it is saying that in an electric field of charge Q, you have got this charge Q which is at the center. Okay. Another charge is carried from A to B. Another charge is carried from, let's suppose this is carried from A to B. Okay. Yes. Then A to C. Then it is carried along this path A to C. Then A to D along this path A to D. Then A to E along this path. The work done will be, we have to find the work done along the path. See, there is one formula. Sir, work done is equal to Q delta V. Sir, if we write this work done, what is the Q? Q is the charge over here. And what is delta V? Sir, guys, listen to me very carefully. Delta V is the final potential energy, final potential minus initial potential. I'll write over here. That is V final minus V initial. Okay. Tell me one thing in this particular case. At this point, what is the potential because of this charge? Okay, what is the potential because of this charge? Or directly, this will confuse you. By this equation, we will get the same answer. But directly you write this equation. W is equal to change in potential energy. Work done is equal to change in potential energy. We say, sir, work done is equal to simply, listen to me very carefully. That is U final minus U initial. Initially, the charge was at this point. So can you tell me initially what is the potential difference between this capital Q and small q? We say, sir, initial potential energy is when the charge is at this point. That is K capital Q small q divided by. What is the distance between them? This is the radius R. So this is R. Finally, the charge is at this point. What is the distance between them? Again, this is the same r. Why? Because this is the radius. This is the radius. Okay. This is the radius. So this is r. So we say final potential energy is also Q divided by r. Now, can you tell me how much will be the change in potential energy? 0, because this minus this will come out to be 0. So work done will be 0. So work done along this path, is 0. Similarly, if you calculate the work done along this path, that will also be 0. Here also it will be 0 using the same approach. So option D is the correct option. 0 along each path. 0 along each path. Find the potential between the two charges. You guys are supposed to tell me what is the potential between the two charges at this point. Find the potential between the two charges at this point. Tell me how much is the potential over here. Guys, see. If we talk about the potential at this point, if we know, see, we say, sir, because of this charge, potential at this point is V is equal to KQ divided by, we say, this distance is R. Okay. And because of this charge, potential at this point will be minus KQ divided by R. Why? Because the charge is negative over here. So can I say net potential in this case is 0? Can I say net potential in this case is 0? Why? Because of this charge at this point, potential is KQ by R. Because of this charge, it is minus KQ by R. We have to write along with the sign. So net will be 0. And if I ask you what is the net electric field at this point, listen to me very carefully. Because of this charge, electric field at this point will be something like this. Electric field is a vector. Potential is a scalar. Because of this charge, electric field at this point will be towards the charge. Okay. And electric field will be 2 times of E over here. And that will be 2 times of, sir, KQ divided by R. Net electric field is not 0, but net potential in this case is 0. Okay. Okay, there is an important statement which I want to tell you. What is that? See, statement is potential decreases in the direction of electric field. Potential decreases in the direction of electric field. Listen to me very carefully. If I say, sir, this is a positive charge. Because of the positive charge, electric field is away from the charge. As you move along the direction of electric field, we say potential will decrease. Means if I am taking the point A over here and point B over here. So we can clearly say potential at A is greater than potential at B. Why? Because potential decreases in the direction of electric field. Okay. Now see, one more point. Sir, when it comes to the electric field at A and electric field at B, the more you are close to the charge, the more will be the electric field. So electric field at A is also greater than electric field at B. Let's come over here. Sir, this is a negative charge. In case of negative charge, electric field is towards the charge. So my dear friends, if we take the point A and if we take the point B, as you move along the direction of electric field, listen to me very carefully. We say potential decreases. So my dear friends, if we are going along the direction of electric field, potential decreases. So potential at A will be less than potential at B. So potential at A is less than potential at B. Why? Let's suppose initially you were here. So potential was, let's suppose 10. As you are moving towards along the direction of electric field, potential is decreasing. Here it is only 5. So that's why VA is less than VB. Then we say electric field at A is greater than electric field at B. Simply. Why? The more close you are to the charge, electric field will be more. Okay. Now. Come over here. Same logic you have to apply in this case also. Now see. Let's solve this particular question. This was asked in NEET 2013. It says that you have got an electric field over here. This is the direction of electric field. A, B, C are the 3 points in the uniform electric field. The electric potential is. We say, sir, electric potential decreases along the direction of electric field. So we say at A, electric potential will be minimum at A, maximum at A. This is wrong. We say maximum at C. Maximum at B. Yes, this is correct. Maximum at B, this is correct. Maximum at C, wrong. Same at all the points. So this is wrong. This is wrong. A option is correct. A option is correct. Why are you saying B option? Maximum at B. This is the point B. This is the point B. Maximum at B. Maximum at B. Maximum at B. Guys, one thing I just want to tell you. Let's suppose if we have a ring. Let's suppose if we have a ring. Radius of the ring is R, and at x distance, let's suppose charge is plus Q on this ring, okay? Plus Q is the charge present on the ring. At x distance, you guys are supposed to tell me the electric potential. Listen to me very carefully. If you have got a ring over here, charge Q is present on the ring. Because of this ring, at x distance, you have to tell me the potential. You will say, sir, it will be KQ divided by under root of R square plus X square. Under root of R square plus X square. KQ upon under root of R square plus X square, that will give you the potential because of the ring. That will give you the potential because of the ring. Now see, listen to me very, very, very carefully. If I say, guys, if X is much less than capital R, means you are taking a ring over here, the radius is R, and X is very small, X is very near in this case. You are taking a point which is very close to the ring. At this point, what will be the potential? You'll say, sir, if any quantity is very small, its square will be more small. Its square will be more small. And this R is large, its square will be more large. Adding small quantity with the small, adding small quantity with the very large quantity, it is not going to create any difference. It's like you are adding bucket of water to the swimming pool. Will it create any difference? No. So we say, my dear friends, in this case, V is equal to KQ upon. We can neglect this X. We can write under root of R square. This will come out to be KQ by R. So means this is the potential near to the ring. This is the potential near to the ring. So if you have got a ring near to the ring, how much is the potential? We say, sir, that is KQ by R. Okay. Now listen to me very carefully. Listen to me very carefully. If I say, if R is much less than X, that is, X is very large. That is very far from the ring. Very far from the ring. That is very far from the ring. Means you have got a ring over here, okay? At very far distance, this is X and this is R. In this case, R is much less than this. You have to tell me how much will be the potential over here in this particular case. You say, sir, we'll take the general formula. What is V is equal to KQ upon. If, guys, R is very small, listen to me very carefully. X is very large, we can neglect this R. So it will be X square, only this and this will cancel. So it will be KQ by X. Simply, I am trying to say is that if you have got a ring, because of the ring very near to the ring, potential is KQ by R. Very far from the ring, potential is KQ by X. As simple as that. As simple as that. Okay. Or even at the center also, we say X is equal to 0. So at center also, we say X is equal to 0. In that case also, potential will be KQ divided by, we say, R. Now, there is a beautiful question on the same concept. That's why I gave you the bit of a theoretical explanation over here. That is, we have got a ring over here. Okay, this is a ring on which plus charge is, positive charge is present. Radius of the ring is R. And we have got one more ring of the same size on which minus Q charge is present. Distance between the two rings is X. X is much greater than R. And this is the point A. This is the point B. You guys are supposed to tell me the potential at A minus the potential at B. That is the potential difference. You guys are supposed to tell me VA minus VB in this particular question. Now see, let's first find VA. Guys, at this point, potential will be because of this ring. At this point, potential will be because of this ring also. Now see, for this ring, positively charged ring, this point is the center. So at center, we say, sir, potential is KQ divided by R. See, because of the ring, the potential at center is KQ by R. So it will be KQ by R. Now, because of this ring, this point is very far from the ring. If the point is very far, we use this distance KQ by X. At X distance, KQ by X. So we say charge is negative minus KQ divided by, we say, X. This is the potential at A. Similarly, if we talk about the potential at B, sir, potential at B will be first, because of this ring which is at the center, that is minus KQ divided by R. Now, for this ring, this point behaves like it is a very far point. So we say this will be plus KQ divided by X. Now, we say we have to find VA minus VB. So VA minus VB will be simply, that is, we can write KQ divided by R minus, we say, sir, KQ divided by X. Okay. And then we say minus, this formula is minus VB. What is the value of VB? Minus KQ divided by R plus KQ divided by X. So further, if you write it, so this will be K, see, this will be minus into minus is plus, minus into plus is minus. So this is plus KQ by R plus KQ by R. So it will be 2 times of KQ by R. So it will be 2 times of KQ divided by R. Okay. Then minus KQ by X, minus KQ by X. So minus 2 times KQ divided by X. Okay. Further, you can solve it over here. See, what I can write in this particular case, sir, VA minus VB will come out to be, see, you can take this twice KQ common, and then it will be 1 by R minus 1 by X. This will be the answer in this case. Is that clear? Is that clear, guys? Is that clear? This was an important question, very important. Next level question. Next level question. Guys, like the session if you have not liked, okay? Let's move on to the next one. We have got a dipole over here. The dipole is placed something like this. This is initially. Then you are rotating the dipole. See, this is the dipole initially over here. Then you are rotating the dipole and finally you make it something like this. Okay. And in this case, you guys are supposed to tell me, find the work done in rotating the dipole from theta 1 to theta 2. Now guys, in this case, theta 1 is 60 degrees. We always measure the angle with dipole moment and electric field. This is the electric field. We say that is 60. How much is theta 2 over here? How much is theta 2 over here? Tell me in the chats. How much is theta 2 over here? We say theta 2 is angle between this dipole moment and this electric field. This is what we call theta 2. And this theta 2 is 180 minus 60, that is 120. So theta 1 in this case is 60. Theta 2 in this case is 120. Okay. 60 degree and 120 degree. 60 degree and 120 degree. Now guys, listen to me very carefully. Listen to me very carefully. I say, if we have to find the work done, how much work it took in rotating the dipole from this position to this position. We say, sir, work done is simply change in potential energy. We say work done is simply, sir, final potential energy minus initial potential energy. UF minus UI. Sir, we say work done is simply final potential energy. How much is the final potential energy? Guys, what is the formula for potential energy? U is equal to minus PE cos of theta. This is the formula. So I can write over here, this is minus PE cos of, we say 120 degrees, because finally it is 120. It is at the angle of 120 degrees. Then we say minus, this formula is minus. Then U initial minus PE cos of, initially it was at 60 degree. Now tell me, sir, this will be minus PE. Cos of 120 is minus 1 by 2. Minus of this minus PE. Cos of 60 is 1 by 2. So I can further write it over here. So this will be, sir, minus into minus is plus. So it will be PE divided by 2. Minus into minus is plus PE divided by 2. So answer is, sir, PE. This is the final answer. This is the final answer. Okay. Now you have the question from the capacitors. Now you have the questions from the capacitors. See, 64 small drops of water whose charge and radius are same. Whose charge and radius are same, are joined to make a big drop, okay? Are joined to make a big drop. So means how many drops are over here joined small, how many small capacitors are joined? It says that in the last class I told you, if we have the small capacitors over here, small capacitors, we can join these to form a big capacitor. Now it is asking that the capacity of the big capacitor is, how much is the capacity of big capacitor? If the capacitance of the small capacitor is C. I told you, in this case, we have a formula. C dash is equal to n raised power 1 by 3 into C. C is the capacitance of the small capacitor. C dash is the capacitance of the bigger capacitor. Now, in this case, it is saying that n is equal to 64 because 64 are joined to form a big capacitor. So we say C dash will be 64 raised power 1 by 3 into, we say, sir, C. That is 4 into cube root of 64 is 4. 4 into 4 into 4 is, we say, 4 times of C. So can we say in this case, it is 4? The capacity of the big drop is the following the times of the smaller, that is 4 times. The capacity of a parallel plate capacitor, if you see a capacitor or a condenser, it is one and the same thing, okay? Is 15 microfarad. We have got a capacitor over here. We have got a capacitor over here, parallel plate capacitor. Its capacitance is, we say, sir, 15 microfarad. When the distance between the plates is 6 centimeter, it is saying this distance over here is 6 centimeter. Okay. And then it is saying, if the distance between the plates is 2 centimeter, finally, we say we are taking the capacitor and we have decreased the distance between the plates. That is how much? We say, sir, 2 centimeters. We are supposed to find its new capacitance. How much is the value of C dash? How much is the value of C dash? Can you tell me the answer of this question? Everybody in the chats. Everybody in the chats. Everybody in the chats. We say, sir, let's talk about the first capacitor. What is the capacitance? C is equal to epsilon naught A divided by D. Sir, capacitance of a parallel plate capacitor is this one. Now, how much is C given over here? That is 15 is equal to epsilon naught A divided by D. In this case is 6. Okay. Now, find in this case. We say, sir, over here, C dash is equal to epsilon naught A divided by D. In this case, we say, sir, 2. This is equation first and this is equation second. Divide first by second or second by first. So we can write, sir, C dash divided by, we say, sir, 15. What's the value of C dash? That is epsilon naught A divided by 2 upon, what is the value of 15? That is epsilon naught A divided by 6. This and this will cancel. It will go over there. So 2 ones, 2 threes, 3 will go 3 into 15 is, so C dash in this case 45 microfarad. An important question. Take a look at this question, guys. I'll come. Give me 2 minutes. I'll go to the washroom and I'll come. Okay? 2 minutes. See, we, we have got this particular question over here. Two condensers, one of capacity C, this is having the capacitance C, another capacity C by 2, this is having the capacitance C by 2, are connected to a battery. Okay. It is like this. You can understand it something like this. You have got one capacitor, you have got one more capacitor, okay, and then the battery is connected to over here. This is V, this is C, and this is C by 2. Something like this. Okay. Now, my dear friends, in this case, you guys are supposed to say the work done in charging the capacitor. See, what is the work done in charging the capacitors? Listen to me very carefully. Sir, the work of the battery is to do the work done. And that work done is stored as the potential in or energy of the capacitor. We say, sir, the work done by the battery. The work done by the battery is stored as the energy of capacitor. Energy of capacitor. The work done by the battery is stored as energy of the capacitor. Keep this thing in your mind. So, if you find the energy stored in this system, means you got the work done. So, we say, sir, work done is equal to energy. And what is energy? 1 by 2 CV square. Now, the question is, what is the value of C equivalent over here? Sir, we say, sir, C equivalent. If the two capacitors are connected in parallel, how to find C equivalent? C1 plus C2, that is C plus C by 2. 2C plus, so that will be 3C divided by 2. So we say, sir, in this case, work done will be simply 1 upon. Instead of C equivalent, I'll write over here, that is, we say 3C by 2 into V square. So that is, we say, sir, 3C by 4, 3CV square by 4, 3CV square by 4. Okay. Is that clear? Now see. Let's move on to this one. Okay. This was asked in NEET 2017. Give it a shot. A capacitor, it is saying that a capacitor is charged by a battery. You have got a capacitor and we have charged this capacitor by a battery. Okay, this is C, battery is B. The battery is then removed. If we then remove the battery, okay, the battery is then removed and identical uncharged capacitor is connected in parallel. And identical uncharged capacitor is connected in parallel. The battery is removed and another identical uncharged capacitor is connected in parallel. Listen to me very carefully. It is saying that, sir, this is the initial case. Finally, the battery is removed and another identical uncharged capacitor is connected in parallel. Guys, this is another identical capacitor which is connected to this one. Can you tell me in this case, sir, we say if we talk about the energy initially, you say, sir, 1 by 2 CV square. As simple as that. Okay. Now, if we talk about finally, sir, this is charged and this is uncharged. When they are connected, they will share the charge. This is Q by 2 and over here it will be Q by 2. And we say in this case, potential difference will be shared. So across this, it will be V by 2. Across both of these, it will be, sir, V by 2. Okay. Now. Can you tell me how much is the energy finally? You say, sir, how much is the energy finally? Final energy in this case will be. Listen to me very carefully. You say, sir, that will be, if this is C and this is C, that is 1 by 2 C equivalent into V square. So you say, sir, U final is 1 by 2. What is C equivalent over here? C and C. So C plus C is, we say, sir, 2C. What is V? Sir, if they have shared the charge, potential has been shared. So if this is 2C and this is V by 2, so it will be V by 2 whole square. So this will be simply, this and this will cancel, C V square divided by 4. Can we write it something like this? 1 by 2, 1 half of 1 by 2 CV square. See, 2 into 2 becomes 4. So 1 by 4 CV square or CV square by 4. Now this is U final. This is U final. Can we write it something like this? U final is, see, this is U initial. This was the energy initially. So U initial divided by, we say, 2. So we say in this case, finally it has been decreased by a factor of 2. Finally, energy. Guys, it is saying that initially we have the capacitor. We charged the capacitor with the battery. So this is the energy stored in the capacitor. Now remove the battery and connect this capacitor with another uncharged capacitor. When you connect it, they will share the charge. They will share the potential. You have to find the electrostatic energy of the final resulting system. This has got energy this much, CV by 4, CV square by 4. So we can also write it something like this, that is initial by 2. So it has been decreased by a factor of 2. Hey, is this clear, guys? Is this clear? Let me know in the chats. Please, please, please let me know in the chats. I want everyone to answer in the chats if this is clear. Please, guys, because that will give me the indication that everyone is understanding. If there are people who never reply in the chats, but right now I am saying you, your teacher is saying you, so you have to reply. Everybody. Tell me. Great, 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 great. Great, 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 great. Sir, guys, like this session as soon as possible. If you have not liked the session yet, like it as soon as possible. Make the like count to 900. Make it 900. Now see. AIPMT 2015. Find the force of attraction between the plates of the capacitor, in terms of CV and D. You say, sir, when it comes to the force between the plates, you say, sir, the two plates attract with a force. Okay, we know, sir, if on one plate positive charge is present, on another plate negative charge is present, they apply force on each other. And that force is, sir, we say Q square upon 2A epsilon naught. But sir, in this case, it has asked in terms of C, V and D. This is in terms of A and Q. We don't want this one. So what we can do is, we can do one thing. Sir, we can write this Q is equal to C into V. So it is square to C square V square. Q is equal to CV upon, we say, sir, 2A epsilon naught. 2A epsilon naught. Now guys, can we do one thing in this case? We can write CV square upon 2A epsilon naught into, sir, we say C. Into, sir, we say C. Again, it is C into C is C square, CV, C square, V square upon 2A epsilon naught. So we say, sir, force in this case will be, sir, CV square by 2A epsilon naught. Can I say, sir, what is the capacitance of a parallel plate capacitor? We say, sir, that is epsilon naught A by D. So I'll put it over here. So this will be CV square upon, we say 2A epsilon naught. Instead of this C, I'll write epsilon naught A divided by D. Now this and this you can cancel over here. So answer will be CV square divided by 2D. See, you got the force in terms of CV and 2D, CV and 2D, CV square by 2D. So this is the answer. This is the answer. Tell me, the potential over here, common potential. In the last class, I gave you the formula. Sir, in order to find this midpoint potential, that is V1, C1, V1, C1, V1 plus C2, V2 plus C3, V3. Then we say upon C1 plus C2 plus C3. This is what I told you in the last class. I hope you remember. I hope you remember. Now, my dear friends, we can say, sir, VC, the potential of this point. C1. C1 is this capacitor, that is 2 into V1 is this potential, that is 10. Okay, then plus C2 is this capacitor, that is 4 into V2 is this potential, that is minus 50. Then we say plus C3 is this capacitor, that is 6. And this is the V3, that is potential, that is 20. Okay. And then we have C1 plus C2 plus C3, that is 2 plus 4 plus 6. 2 plus 4 plus 6. Solve it and get the answer. Let's move on to this one. I guess we did the same question in the last class. This is what we did in the last class. Done already. Hey, yes or no? We did this question in the last class. Okay. Now see. See guys. We have got find the potential drop across each capacitor. We have got the 3 capacitors over here. 5 microfarad, 10 microfarad and 30 microfarad. Listen to me very carefully. We say 3 capacitors are connected in series. I'll tell you the trick. Remember this trick. Remember this trick. Guys, can I say in this particular question, see, as we say Q is equal to C into V. Guys, we have got the 3 capacitors and we have to find the potential difference across each capacitor, across this, okay? We say we know the formula Q is equal to C into V, okay? Now tell me one thing. Remember, sir, in series combination, Remember one thing always. Sir, charge in all the capacitors is same. We say charge, Q is same, Q is same, Q is same. So means in series combination, the charge stored here will be equal to here, will be equal to here. If charge is same, listen to me very carefully. If charge is same, can I say, sir, Q divided by this C is equal to V? Now this quantity is constant, this quantity is same. So we say V is proportional to C. So we can write V is proportional to C. We can write V is proportional to C. Means in series combination, listen to me very carefully. In series combination, the one which has got more capacitance will have the less voltage. The one which has got more capacitance will have the less voltage. So the one with more capacitance will have less potential difference. Okay. Now guys, how to solve this question? Sir, 30, 10 and 5. 30 is having more capacitance, so it will have less voltage. It will have less voltage. So I can say, let's suppose across 30, I am saying the potential difference is X. Let's assume it X. Can you tell me what will be the potential difference across 10? Sir, this is 30. 30 is how many times bigger than 10? 3 times. And this is 3 times smaller than 30. So across this, it will be 3X. And 5 is how many times smaller than 36 times? So across this, it will be 6X. I hope you got it, sir. The capacitor which has got more capacitance will have less voltage. Here, 30 microfarad will have less voltage. That is X. Across 10, it will be having more voltage as compared to 30. That is 3X. Across this, it will be 6X. Now, how much is the net voltage of the battery? That is 100. So this 100 is only getting distributed over here. Listen to me very carefully. This 100 is getting distributed in V1 plus V2 plus V3. And in this case, V1 is, let's suppose, 6X. So we say, sir, this 100 is. V1 is potential difference across this, that is 6X. Plus potential difference across this, that is 3X. Plus potential difference across this, that is X. So can I say this 100 is equal to, we say, sir, 10X. X is equal to, we say, sir, 10 volts. Yes. So X is what? X is V1. So V1, sorry, X is one, sorry. X is this V3. So we say which is equal to V3. If I tell you what is the value of V2, we say V2 is 2X. So that will be 20 volts. If I say what is the value of, sorry, 30 volts, 3X, that is 30 volts. If I say what is the value of V1, that is 6X, that will be 60 volts. I hope you got this technique. I hope you got this technique. This is very important. Let me show you one more on this. Okay, this is the question that you have over here. This is the question that you have over here. Solve it. Let me know. Find the potential drop across each capacitor. Find the potential drop across each capacitor. Find the potential drop across each capacitor. Tell me, guys. Find the potential drop across each capacitor. Tell me. See, I'll tell you. I will tell you. My dear friends, I am saying that Q is equal to C into V. So Q divided by C is equal to V. In series combination, we say, sir, Q is same. Okay. So we say V is inversely proportional to C. So the one which has got more capacitance will have less voltage. In this case, we say across 18 microfarad, it is voltage is X. Across this 6 3s are 18, so it will be 3X. Because 6 is how many times smaller than 18? 3 times. Across this, it will be 3 6s are 18, so 6X. Now, can I say net voltage is 10? I can say 10 in this case is 10 is equal to, we say, sir, 6x plus, because this voltage will only get divided in this, and in this. 6x plus 3x plus x. Now this is 10x. 10 is equal to, we say, sir, 10x. X is, we say, sir, 1 volt. So if x is 1 volt, can I say, sir, 3x in this case is, we say, sir, 3 volts. 6x in this case is 6 volts. Means this battery is giving 6 volts to this, 3 volts to this, 1 volts to this. Total is 10 volts. This is the answer. One more important question. In this case, find the charge in this capacitor, and this capacitor. We are supposed to find the charge in all the 3 capacitors over here. We are supposed to find the charge in all the 3 capacitors over here. Tell me. See, guys, once again, we'll use the same concept. As Q is equal to C into V. Okay. We say in parallel combination. In parallel combination. Listen to me very carefully. In series combination, we say charge is same. But in parallel combination, we say potential difference is always same. We say the potential difference across this equal to this equal to this. Remember this. In parallel combination, we say potential difference is same. V is same across all capacitors. Even across all resistors also, you can say. So we can say if this V is same, so means Q is directly proportional to C. Means Q is directly proportional to C. Okay. Now, my dear friends, if Q is directly proportional to C, listen to me very carefully. Listen to me very carefully. I can say, if Q is directly proportional to C over here, I can say, sir, the one which has more capacitance has more charge stored in it. Has more charge stored in it. Okay. Now see, we have got 3 microfarad, 9 microfarad and 10 microfarad. Clearly we can say, sir, this is having the more capacitance, so more charge will be stored in this capacitor. Let's suppose in this it will be X. Sorry. Let's suppose in this it will be X. This is how many times bigger than 3? So we say, sir, 3 times. 3 into 3 is 9, so it will be 3x. 3x will be stored in this one. So this is how many times bigger than this one? 6. So this will be 6x. Okay. So in this case, Q1 is, we say, sir, x. Q2 is 3x. Q3 is 3x. 6x. So means if charge is coming over here, Q1 goes in this one, Q2 goes in this one, Q3 goes in this one. And we say, sir, net charge over here is always equal to Q1 plus Q2 plus, we say, sir, Q3. And we say Q1 is x plus 3x plus 6x. And net charge is how much? 100 microcoulomb. So this is, we say, sir, 10x is equal to 100. 10x and x in this case will be, sir, 10 volts. So x is 10 volts. If x is 10 volts, can I say, sir, Q1 will be, sir, simply 10 volts. Sorry, 10, not, this is, we are finding charge, 10 microcoulomb. 10 microcoulomb. So this will be 10 microcoulomb. And Q2 will be, we say, sir, 3x, that will be 30 microcoulomb. Sir, we say Q3 will be 6x, that will be 60 microcoulomb. So if 100 microcoulomb is entering, we say over here, 10 microcoulomb gets stored in this, 30 gets stored in this, 60 gets stored in this. Hey, is this clear? Tell me in the chats, everybody. Yes, Wasim sir will upload the PDF of that session. Don't worry about that. Tell me, guys, is this clear? Is this clear to each and everyone? Is this question clear? Because this is important. Is this question clear? All the people out there, give me the signal in the chats. Is this clear? Let's take a look at this particular question. Find the equivalent capacitance in this case. Okay, this is we are already done. Already done in the last class. Okay. Let's move on to this one. Yeah, this is a good question. On the same pattern. On the same pattern. Now see. Sir, in order to solve this pattern of question, what are we supposed to do? Let's suppose this is the point P. We say, sir, if it is having the potential P, this will also have the same potential P because this is the straight wire going till over here. Now, we can similarly say this will be also having the same potential P. But you can't say this has the potential P. Why? Because capacitor came in between. Now, this point is having the potential Q. Can we say this point has the potential Q? Tell me in the chats. We say, sir, no. Why? Because capacitor came in between. If there was a straight wire, simple wire only, then we would have said, yes, over here also it is Q. Now, tell me one thing, my dear friends. Tell me one thing. If this is Q, let's suppose we introduce new potential. Let's suppose the potential at this point is X. We are introducing. Third point we are introducing. This is the technique that we use. Introduce new point that is X. So we say at this point also it will be X. At this point also it will be X. Okay. So you are done with marking the potential on the figure. What is the first thing that you guys are supposed to do now? We say draw all the points on the screen over here. Now see, we say what is the first point? We say, sir, P. What is the next point? We say, sir, X over here. This is X. This is X. This is X. What is the next point over here? We say, sir, Q. Only 3 points are over here, which I have mentioned. And rest CCC is the capacitance. Now let's talk about the first capacitor. First capacitor is connected between, we say, sir, P and X. So I'll make it between P and X. Sir, this second capacitor is connected between X and P. So I'll make it over here. This is between X and P. Sir, this third capacitor is also connected between P and X, so I'll make it over here. Sir, this capacitor and this capacitor, don't you think they are connected between same potentials or same ends? So we say both of these will be short circuit. So means you can remove these, remove. And then the last capacitor is between X and B. So that will be over here between X and Q. This is Q, X and Q. This is C, this is C, this is C, this is C. Now tell me one thing. Clearly we say, sir, this C, this C, this C. All the three are in C, parallel. So they will be having the equivalent capacitance. We say, sir, 3C, C plus C plus C. And this one is in the series. Now listen to me very carefully. Listen to me very carefully. When the two capacitors are in series, how do we find the equivalent? 1 upon C equivalent is equal to 1 by C1 plus 1 by C2. Now multiply it. If you do the cross multiplication all, finally it will come out to be C1 C2 upon C1 plus C2. Same I'll use over here. So we say C equivalent in this case will be C1 equivalent of this, that is 3C. Then you have equivalent of this is in series with this C. 3C into, we say, sir, C divided by 3C plus C. C1 C2 upon C1 plus C2, because if you make the new figure of this, equivalent of these is, we say, sir, 3C, and then you have got this C over here. Equivalent of this is given over here. 3C into that is 3C square upon 3C plus C is, we say, sir, 4C. This and this will cancel, 3 by 4C. So net capacitance across PQ is 3 by 4C. Net capacitance across this is 3 by 4C. Okay. Let's talk about this one. This is the point A. And one more, this is also joined. This was also joined with this. Okay. This is C, this is C, this is C, this is C. You guys are supposed to tell me what is the equivalent capacitance, not this. Find C equivalent across AB. 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 See, guys, tell me one thing. If this point has the potential A, can I say this point will be also having the same potential A because this is a straight wire? And then also it is the simple wire, only over here it will be A potential. And if this potential is B, this potential is also B. In this entire circuit, how many points are there? We said 2. Which one? A and we say, sir, B. In this entire circuit, we say there are only 2 points, A and B. Okay. Now, let's talk about these two capacitors. We say, sir, these two capacitors are connected between A and A, same point. We say, sir, they will short circuit. So you can remove. Now, this capacitor is connected between A and B. So you can connect it something like this. And this capacitor is connected between A and B. So you can connect it something like this. So this is C, this is C. So can you tell me C equivalent in this case will be, we say, sir, 2C. C plus C is 2C. Okay. This question. The total energy stored in the condenser system will be how much? Will be how much? This is a system over here. Guys, don't you think that, sir, these two are in series? These two are in series. And their C equivalent will be how much? Their C equivalent will be how much? We say, sir, 3 into 6 divided by 3 plus 6. C1, C2 upon C plus C2. We have to find the net capacity. We have to find the energy stored in this entire system. Oh, how to find the energy stored in the entire system? 1 by 2 CV square. Now, this is C equivalent over here. So, C equivalent means equivalent of these capacitors. Okay, find that first. Put it over here and then solo. So, we say that will be, sir, this is 2. 6 into 3 is 18. 6 plus 3 is 9. 9, that is 2. Now, equivalent of this, listen to me very carefully. I'll make it over here. This is 2, not ohms, 2 microfarad. Okay, then you have got this 2 over here. You have got this 2 over here. Equivalent of these two is 2, and then you have got this 2 over here. And then you connect a battery, that is 2 volt battery. Then you connect a battery, that's a 2 volt battery. Okay. Now tell me one thing, my dear friends. 2 and 2 are in the parallel. We say, sir, their equivalent will be, sir, 2. Their equivalent will be 4 because C1 plus C2. First, you find the equivalent of these two, then with this one. So final C equivalent is coming out to be 4 and this is 2 volts. Okay. Now tell me one thing. I can say, sir, U is equal to 1 by 2 C equivalent. C equivalent is 4. V equivalent, that is 2 square. So U is equal to, we say, sir, 2 ones, 2 twos. 2 square is 4. 4 twos are 8 microjoule. Is that clear? Is that clear? I hope this question is clear. First find the equivalent capacitance, then use the formula U is equal to 1 by 2 CV square and you will get the answer. Now see. This was the question which was asked in JEA mains 2022. This was the question which was asked in JEA mains 2022. I want you guys to give it a shot. I want you guys to give it a try. Okay? Guys, if you have not liked the session yet, I want you guys to like the session as soon as possible. Give it a try. Tell me which option. Solve it, guys. Read the question very carefully and solve it. It is very simple. Because I have shown you already 2-3 problems on the same pattern in the yesterday's class. That's the reason I have put up this over here. See. What does the question say? For changing the capacitance of a given polar plate capacitor, a dielectric material is used as a constant K. Okay. It is saying that we have got a polar plates over here. Let's suppose this is one plate. Okay. And we have got one more plate over here. We have got one more plate over here. Got one more plate over here. Okay. Yes. Now, it is saying in this polar plate capacitor, listen to me very carefully. We have used a dielectric. This is a dielectric. Okay. This is a dielectric. Let's suppose this one. This is a dielectric. And this dielectric is having the dielectric constant K. Okay. And the width of this slab is, we say, 3D by 4. If total width is D. My dear friends, we have got a capacitor. The area of the plates is A. In between the capacitor, we have used a dielectric constant K is used, which has the same area as the area of the plates. The thickness of the slab is 3D by 4, where D is the separation between the plates, the new capacitance. We are supposed to find the new capacitance of this capacitor. Okay. This is air over here. Okay. And can you tell me how much will be this distance? We say, sir, D minus 3D by 4. This will be D by 4. If you say D is the total distance. D minus 3D by 4. This is D by 4. Now you guys are supposed to find in this case the new capacitance. Okay. So we say, sir, new capacitance will be, listen to me very carefully. I have told you in the last class, if we place a dielectric in between the capacitors, its capacitance changes. So that is new capacitance is epsilon naught upon into A. Then we say D1 by K1. I hope D1 by K1 plus D2 by K2. I hope you remember this formula. So we can say this is epsilon naught A upon, what is the value of D1 over here? Means width of this, that is 3D by 4. 3D by 4. And what is the value of K1? That is K. This is K. Okay. Then we say plus D2 by K2. What is the value of D2 over here? That is D by 4. Okay. And what is the value of K2? For air, we say, sir, K is 1. So this is D by 4 only. Now, can you solve this particular equation? I'll write over here. C is equal to epsilon naught A upon D 3D by 4K plus we say D by 4. Okay. Now tell me one thing. We can do one thing in this case. We can write C is equal to epsilon naught A upon. We can take D by 4 common. Okay. Then what remains over here? 3 by K plus 1. 3 by K plus 1. Okay. So what we can say, sir, C is equal to epsilon naught A upon. This is K plus 3 by K, and take that K over here, 4 over here. So this is D, and then it will be K plus 3. After simplifying this and all and reshuffling, this will be the. Now we say, sir, this is C dash, this is C dash, this is C dash, new capacitance. C dash, new capacitance. Sir, without dielectric, we know, sir, without dielectric, What is the capacitance? We say, sir, that is C is equal to epsilon naught A divided by D. This is the capacitance without the dielectric. So we say this C dash will be epsilon naught A by D. Instead of this, we'll write, sir, C. And then we say, sir, 4K divided by K plus 3. C4K plus K by 3. C4K, or it is mentioned, it has mentioned C naught over here. So you write C naught. C naught 4K, C naught 4K, K plus 3. C naught 4K, K plus 3. Okay. Let's talk about these types of questions. Guys, I have shown you every pattern of question. Every pattern we have discussed. Literally. Now, these are what we call the plates. Plates of capacitor. Okay. Now, if I tell you how many plates can form one capacitor? We say, sir, clearly 2 plates can form one capacitor. This is one plate and this is one plate. They form one capacitor. This is second capacitor and this is third capacitor. Okay. Yes, sir. Now tell me one thing. Sir, this plate is connected to X. Let's suppose the potential of this plate is X. We have to find, listen to me very carefully. We have to find the net capacitance of this system. In this case, they will give you the plates. They will give you the plates in the question, and they might ask you to find the net capacitance. Now see how to solve this. We said this plate is connected to the point X. Okay. This plate is connected to the point Y. Let's introduce one more point, that is A. That is A. This plate is connected to A. Can I say, sir, it is directly connected to this, so over here it will be also same potentially? Yes. Now, the second thing what you are supposed to do is draw all the points on the board. How many points are there? X, then you have got A, then you have got Y. X, A, Y. Now, the third point you guys are supposed to do is, sir, this first capacitor is connected between X and A. So I'll make it over here. This is connected between X and A. So I'll connect it over here. This is connected between X and A. Second capacitor is connected between X and Y. So it is connected between X and Y. Third capacitor is connected between Y and A. So I'll make it over here. I'll make it over here. Something like this. So this is C, this is C, this is C. First is connected between X and A, so this is X and A. Second is connected between X and Y, so this is X and Y. Third is connected between A and Y, so A and Y you can see over here. Now it is easy. Sir, in this case, clearly we can say, sir, these two capacitors are in series. So their equivalent will be C by 2. When the two capacitors are in series, their equivalent is, we say, sir, C by 2. This is C by 2, okay? And then you have this C connected over here, this is C. Now tell me, if this is C by 2 and C, what will be the net equivalent in this case when the two capacitors are in parallel? We say, sir, C by 2 plus C. That will be 3C by 2. So net capacitance of this particular system is 3C by 2. 3C by 2. Okay. Let's move on to the next one. Okay. This is the next question we have over here. This is the next question. We say find the net capacitance of the system. Find the net capacitance of the system. Tell me. See, this plate is connected to A. Let's suppose mark one more point, that is X. So if this is connected to X, so this is also connected to X. Or you can understand it something like this. The potential of this plate is A. The potential of this plate is X. And the potential of this plate is B. What is the first thing that you guys are supposed to do? What is the first you guys are supposed to do? What is the first thing you guys are supposed to do? You have to mark all the points over here. So we say, sir, A, then we say, sir, X, then we say, sir, B. 3 points, okay? Now, my dear friends, first capacitor, this is the first one, this is second, and this is third. First capacitor is connected between A and X. So this is connected between A and X. Second capacitor is connected also between A and X. So this is also connected between A and X. Third capacitor is connected between, sir, X and B. So this is connected between X and B. This is C, and this is C. Now the equivalent of these two is, we say, sir, that is C. Sorry, that is 2C. Equivalent of these two is C plus C is 2C, because whenever the two capacitors are connected in parallel, their equivalent is 2C. And then you have over here this C. Sir, equivalent of these two will be how much? We say, sir, whenever you have two, you write C1, C2, C1 plus C2, because in series combination, this is the formula. So we say, sir, that is 2C into C upon 2C plus C. So that is 2C square upon, we say, sir, 3C. This and this will cancel. 2 by 3C. Is that clear? Is that clear? Is that clear, guys? Is that clear? Let's solve this question. Okay, let's solve this question. See, you have got one plate, 2, 3, 4. Now here you have got point A. Find the net capacitance of the system. Find the net capacitance of the system. Now see, if you have to find the net capacitance of this system, we say, listen to me very carefully. Listen to me very carefully. Guys, let's talk about this first this plate. If this is having the potential A, means this plate will be also having the potential A. Now, if this end is having the potential B, so this end will be also having the potential B, because it is going directly till over here. So we said this lower plate will be also having the same potential B. It is going directly till over here. So if this is having the potential A, this will be also having the potential A. Okay. Now tell me one thing. Sir, this first capacitor, this is the first capacitor, this is second capacitor, and this is the third capacitor. Three capacitors are formed over here. Now, if we take a look in this case, this second capacitor is connected between B and B. So across this potential is B, across this potential is B. So it is connected between same potential. So this will be short circuit. Okay. Now, first capacitor is connected between A and B. Let's suppose mark the point A and B. It is connected between A and B. Let's make it something like this. This capacitor is also connected between A and B. Let's make it something like this. So this is C, this is C. So answer in this case will come out to be, we say C equivalent in this case is, we say, sir, 2. Okay, let's talk about this question. Let's talk about this question. See, you have to find the equivalent capacitance. Find C equivalent. Guys, this is the point A. Can I say this point has also got the potential A? Okay. And then you have got this one. Listen to me very carefully. This is the point B, and this point has got the potential B. Now, this capacitor, and this capacitor. See. First of all, how many points are over here? A and B. Only A and B. So I'll write A and I'll write B. Now, this capacitor, and this capacitor, they are connected in series. So we say instead of these three, I'll write over here one, that is C by 3. That is C by 3. Guys, three capacitors are connected over here in series between A and B. So I'll write C by 3. And then last capacitor is connected between A and B once again. So I'll write over here, this is C. So can I say in this case, C equivalent will be C by 3 and this C, that is C by 3 plus, we say, sir, C. That will be 3C plus C, that is 4C divided by 3. 4C divided by. Okay. Next, this one. Find the net capacitance. Let's suppose you have got the capacitor over here, capacitor over here, capacitor over here, capacitor over here. And this is the point, let's suppose they are connecting by means of this circular wire. So can I say, let's suppose if I say potential of this is B at the center, C. At the center, we say, sir, potential is A. Then potential of this point, let's suppose if it is B, we say this will also have B, this will also have B, this will also have B. All will have we say all will have the same potential. Just a second, guys. Let me adjust the lights over here. Now see, take a look over here. So if we say all of these capacitors are connected over here between A and B, all of these capacitors over here are connected between A and B. Okay, okay. So we say, sir, this is A, and then we say, sir, this is B. Let's talk about this capacitor. It is connected between A and B, so let's make it something like this. This one is also connected between A and B, something like this. Third one also something like this. Fourth one also something like this. So this is C, 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 C. So C equivalent in this case is, we say, sir, 4C. Okay. Now, after this, we have to start the current electricity problems. Okay. So we'll take the break. Break till 1:35. Okay. Break till 1:35. Guys, we have to finish all of these questions. Okay. Don't go anywhere. So people, let's start. So we have the first question on the screen over here. Take a look. See. Let the people join back. So we are given a question over here. Q is equal to T cube e raised power minus 4t. And find time when current changes its direction. We are supposed to find the time when current changes direction. Okay. We are supposed to find the time when current changes direction. Remember the general approach. What is the general approach? If you ever see a question something like this, Q is equal to, we say T raised power A, okay, E raised power minus BT. And then they ask you find the time when current changes direction. Like this is the Q, this is the charge is flowing. Like let's suppose you have got a conductor over here. In this conductor, charge is flowing according to this relation. Okay. And current will be flowing. Current has a direction. So if it says find the time when current changes direction, you simply say, sir, that time will be, we say, sir, A divided by B. Simply it will be, sir, A divided by B. Like you have got the question over here. In this question, can I say this is Q is equal to T cube? Here you have got A, you have got 3. And then you say E raised power minus 4t. You have got over here B, you have got over here 4. So we say find the time when current changes direction. We say, sir, that time will be A by B and that is 3 by 4. That time will be 3 divided by 4. As simple as that. Okay. Now let's suppose, next question we have. In a conductor, drift velocity is doubled and radius is halved. Find the new current. See, let's suppose we are given a conductor over here. Okay. In this conductor, drift velocity of electrons is Vd. Drift velocity is that velocity with which electrons flow. And current in this case is, let's suppose I, radius is given as R. Can we use the formula, sir? We know, sir, current is equal to NEA, we say, sir, Vd, where N is the number of free electrons per unit volume, E is the charge on an electron, A is the area of cross section, Vd is the drift velocity. So can I say over here, sir, this current will be simply NE. Instead of area, I can write pi R square and then we say Vd. Okay. Now take a look at the question. It says if the drift velocity is doubled. If I say, sir, if Vd dash drift velocity becomes 2 times of Vd. Initially it was, sir, Vd. Drift velocity of the electrons was Vd. Now it is saying drift velocity is doubled. And radius R dash is halved. Okay. Radius becomes half. And we are supposed to find the new current in this case. Sir, can I say new current I dash will be NEA, okay, and we write A dash, and then we say, sir, VD dash, and I'll write over here NEA. Instead of area, can I write, sir, this is pi, and what is the radius right now? That is R by 2, so this will be R by 2 whole square. And then we say VD, sir, VD dash is how much? That is 2 times of VD. So I can write over here, this will be R by 4, 4 into 2. So finally it will be NE pi R square VD divided by, we can write over here 2. Okay. Okay. Now my dear friends, tell me one thing. Sir, we know I is equal to NE pi R square VD. So NE pi R square VD. Instead of this, can I write I over here? So finally I can write this I dash is equal to, we say, I divided by 2. I dash is equal to I divided by 2. Okay. Now this problem. two wires A and B having the same material. Let's suppose we are given the two wires over here. Okay. A and B. This is the wire A and this is, we say, we have got wire B over here. Having same material, having the radii in the ratio of 1:2. Radius of this is given as 1. Radius of this is given as 2. Okay. Carry the current in the ratio of 4:1. Current in this conductor is given as 4. Current in this conductor is given as 1. 4:1. Okay. The ratio of the drift velocity of the electrons. We are supposed to find V1 and V2. What is the ratio of drift velocity of electrons? That's we are supposed to calculate. Okay. Now tell me one thing, my dear friends, in this case. We say, sir, when it comes to the drift velocity, sir, drift velocity is equal to, see, as we know the formula, I is equal to NE, instead of A, I'll write pi r square and then we say VD. Now, if we have to find this VD, can we write, sir, drift velocity of electrons as we say, sir, I upon, that is NE pi r square. Yes. Now tell me, in case of this conductor and this conductor, we say, sir, number of free electrons per unit volume is same because it is made up of same material. Sir, charge on an electron is same, pi is same. So drift velocity depends upon current and this. So we say VD is I divided by r square. So drift velocity in this case only depends upon I by r square. Now tell me one thing. Can I just write over here the drift velocity in first case divided by drift velocity in second case, in second wire? I'll write that. Sir, what is the current in the first wire? That is 4. So I1. I write over here VD is equal to I1 divided by, first we'll write the formula, divided by R1 square. R1 square divided by, we say, sir, I2 upon R2 square. Okay. Now, can we write over here, what is the value of I1? What is the value of I1? I1 is 4 and R1 is 1. We say, sir, 4 divided by 1 upon. What is the value of I2? Sir, value of I2 is 1. Value of R2 is 2. So this is 1 divided by 2 square. 1 divided by 2 square. Yes. So 2 square is 4. If you go over there, so it will be 4 into 4 is 16. So 16:1 is the ratio. So drift velocity V1 by V2 is coming out to be, we say, 16:1. Option A, 16:1. Take a look over here. Guys, this is voltage versus current graph. This is voltage versus current graph. I have told you in case of, we say VI graph. In case of VI graph, we have clearly discussed that, sir, slope is proportional to resistance. If you find the slope here, that means resistance. In the last class we discussed. So if you find the slope in case of VI graph, means you are finding the resistance. Now it is saying that find the ratio of resistance of A and B. We have got the wire over here, that is A. We have got another wire over here, that is B. And we have to find the ratio of the resistance. So what will you do in that case? You will find the slope of A divided by, we say, sir, slope of B. Okay. That will be simply, sir, we can say resistance of A divided by, that will be resistance of B. And how to find the slope? We say, sir, slope means tan of theta divided by tan of theta. Now the question is, if you have to find the slope of this wire, you say how much it is making, tan of 30 degrees. So you write over here, sir, this one is making, we say, sir, 60 degrees because over here this is 30. So we say tan of 60 degrees divided by tan of 30 degrees. Put the values and get the answer. Okay, 3:1. Now, next question we have. The resistance of a conductor is R and the length is L. The resistance of a conductor is R and the length is L with the radius R. Okay. If the length is doubled and radius is doubled, find the new resistance. Guys, see. We have got a conductor over here. We have got a conductor over here. Okay. It is saying that its resistance is R. Can I say this resistance will be rho L divided by A? Yes, sir. And we can more specifically write it rho L. L is the length of the conductor. A. Area means pi r square. This is pi r square because its radius is given as R. So it will be pi r square. Now it says that if the radius, if the length of the conductor is doubled, it says if length becomes 2L. Initially the length was L. Now it says that we have increased the length. Length becomes 2L. Okay. If the length is doubled and the radius is also doubled doubles, R dash is, we say, sir, 2R. We have to find the new resistance in that case. How will we find? We say, sir, resistance is equal, R dash is equal. I say, sir, rho L dash divided by A dash. So can I write, sir, rho instead of L? We say we'll write 2L over here. Why? Because length has been doubled. Divided by, sir, area. Area means I'll write over here pi r square, R dash. What is R dash? That is 2R over here. Okay, and this is square. So this will be, sir, 2 rho L upon 4 pi r square. 2 ones, 2 twos. So R dash will be simply rho L by pi r square. Rho L by pi r square is initial resistance. So R divided by, we have got this 2 over here. So you can divide this 2. This is the resistance. So resistance becomes R by 2. Means in a conductor, if you double the radius and if you double the length, we say, sir, resistance becomes half. Okay, this question. This point is having the potential, let's suppose VA is equal to plus 8 volts. You guys are supposed to find the potential of VB of this end. Current in this case is 2 ampere. In the last class, I have shown you some of the great questions on this particular concept. How do we solve this question? We first select the path. Okay, let's suppose we are selecting the path from A to B. Okay. Then we write the potential VA over here. This is the potential VA over here. And this is the direction of current, means this is positive and this is negative, because current always flow from higher potential to lower potential. Current flows from higher potential to lower potential. Since in this case, can you tell me how much is the potential difference? V is equal to IR. I is 2, 2 into 6 is, we say, sir, 12 volts. And we are going from lower to higher, from minus to plus. So means we will take the potential drop as positive, then we write 12 volts. First you write this VA, then the potential difference of this as 12 volts. How to find that? V is equal to IR. Shall we take it positive or negative? We say positive because we are moving from minus to plus. If our path was plus to minus, then we would have said minus. Is equal to, we say, sir, we reach over here, that is VB. Okay. So we can simply say VA minus VB in this case will be minus 12 volts. Okay. Is this clear? Okay, okay. VA is given. We are supposed to find VB. Cool, cool, cool. So VA in this case is, we say, sir, 8 plus, we say, sir, 12 is equal to, sir, VB. So VB will come out to be, in this case, 20 volts. Will come out to be 20. This question, important. This is the point A and this is the point B. You guys are supposed to tell me in this case, what is the value of VA minus VB? What is the value of VA minus VB? In this particular case, you guys are supposed to tell me what is the value of VA minus VB. Tell me, guys. What is the value of VA minus VB? See, guys, if you have to find VA minus VB, what is the first thing that we exactly do? That is select the path. Select the path. This is the first thing that we do. So you'll be selecting the path over here. You'll be selecting the path over here. That will be something like this. Okay. From A to B. From A to B. Now see. We say, sir, this is 1 ampere current. This is 3 ampere current. Can we not say, sir, it would have been 4 ampere current from here? Sir, this 4 ampere is only getting divided 1 ampere and 2 ampere. This is the Kirchhoff's current rule. Some people were saying that in the last class, sir, you didn't teach it. This is the rule. The current entering the junction is equal to the current leaving the junction. Sum of all the currents entering this junction will be equal to the current leaving the junction. If 3 ampere is going in this from this way, 1 ampere is going in the upward direction. We say how much is the current which is entering this junction? 4. 3 plus 1 is 4. We say here also it will be 4. Now 2 ampere current is coming something like this. This is 2 ampere. If this is 2 ampere and over here it is 4 ampere, can we not say 2 ampere would have comes from this path? So this 2 and 2 meets over here, then 4 leaves, and then again it gets divided into 3 and 1. Okay. Now see. We say, sir, direction of current is this, means this will be positive and this is negative. Because current always flows from higher potential to lower potential. This will be positive and this will be negative. Current flows from higher potential to lower potential. Now, in this case, direction of current is this. So this will be positive and this will be negative. Because current flows from higher potential to lower potential. Okay. Now see. First of all, we'll write if we are moving from A to B, first of all, we'll write the potential of A, that is VA. Then potential of this resistor, how much that is? Sir, that is V is equal to IR. VI is how much? That is 2. R is how much? That is 4. So I into R in this case is, we say, sir, that is 4 into 2, that is 8 volts. So I'll write 8 volts over here. Now the question is, shall I write plus 8 or minus 8? Since we are moving from positive to negative, this is the direction of our path. Positive to negative, so we say this will be minus 8. Okay. Then come over here. In case of the battery, we are moving from lower potential to higher potential. So we say this will be from lower minus 3 to from lower to higher. We say, sir, this will be plus 3 volts. Okay. Then in this resistor, what will be the potential difference? I into R. I is how much? That is 2 ampere. 2 into 2 is, we say, sir, 4 volts will be over here. So we'll write 4 volts. Now, again, we are moving from higher to lower. So this will be minus. Okay. Now come in this resistor. Sir, in this resistor, how much is the potential drop? I into R. I is 2. R is 1 ohm. 2 into 1 is 2 volts. So it will be 2 volts over here. So I'll write this 2 volts over here. Now the question is, shall I take it positive or negative? We are moving from lower to higher because this is the direction of the path. This is the direction of the path. So this will be plus 2 volts. Okay. Is equal to, we say, sir, VB. I hope I did not make any sort of mistake over here. Okay. Now see. Now this is VA. Then we say 8. This is minus 12 plus 5 is equal to VB. So 12 minus 5 is 7. So VA minus 7 volts is equal to VB. So now VA minus VB is equal to 7 volts. Is 7 correct? Is 7 correct, guys? Is this clear? This is almost 6th or 7th question on this particular topic. Okay. Chalo, this is one more question on the same topic. See, guys, we say 2 ampere is the current in this branch, 5 ampere is the current entering. So can I not say, sir, 3 ampere would be leaving, something like this? Sir, 2 ampere plus 3 ampere is 5 ampere. Okay. Now in this resistor, we say current flows from higher to lower. So this is positive and this is negative. And in this resistor, this is the direction of current. So this will be positive and this will be negative. Because current flows from higher to lower. It flows from higher to lower. Okay. Now we have to find in this case, find VA minus VB. This is what we are supposed to calculate. First of all, we'll select the path. Let's select the path from A to B. So we selected the path from A to B. So if we are selecting the path from A to B, we'll write the potential of VA first. So I'm writing the potential VA first. Then comes the battery. So in battery, we are moving from negative to positive, lower potential to higher potential. We take its potential drop as plus 6 volts. Then in case of resistance, can you tell me how much is the potential difference in the resistance? You say, sir, V is equal to I into R. I in this case is 3 ampere. R in this case is 5. 3 into 5 is 15. So I write 15 volts over here. Now the question is, shall I take it plus 15 or minus 15? Now the question is, shall I take it plus 15 or minus 15? So we say in this case, we are moving from lower to higher. So we say plus 15. Now come over here. In this case, how much is the potential difference? 2 into 2, I into R. 2 into 2 is 4 volts. Okay. And we are moving from higher to lower. So it is minus 4. Then in this case, 8 volts, but it has to be minus 8 because we're moving from higher potential to lower, is equal to, we say, sir, VB. Now tell me, in this case, this is VA plus 21 volts minus 12 volts is equal to VB. Okay. Is this correct, guys? Is this crystalline clear to each and everyone? Is this crystalline clear? So we say VA minus VB will come out to be 9 volts. I hope this is clear. Okay. Find the potential drop across each resistor. Guys, similar type of questions I have shown you in the capacitor. Similar type of questions I have shown you in the capacitor chapter. Similar type of questions I have shown you in the capacitors. Listen to me very carefully. The 3 resistors are connected in series. Okay. Can I say as V is equal to I into R? You will remember this technique over here also. You will remember this technique in the current electricity also. We say V is equal to I into R. Now, my dear friends, we say in series combination, we say current is same across all the resistors. In case of capacitors, we used to say in series combination, charge is same in all the capacitors. Okay. Now see, if I say in series combination current is same, so can I say V is directly proportional to R? Yes. What does that mean? That means the one with more resistance, the one with higher resistance has higher potential difference across it. So in all the 3, which one is having the higher resistance? We say, sir, 18 ohm. So across this, the resistance will be more. So let's suppose if I say across this potential difference is X, can I say across this it will be 2X? Because 6 is 2 times greater than 3. Okay, if it is X, so this is basically 2X. And across this will be 6X because 18 is 6 times greater than 3. Now tell me, in this case, this is the potential difference across this plus potential difference across this plus potential difference across this. So we say this will be 10 is equal to, we say X plus 2X plus 6X. Okay. So we say 10 is equal to, we say, sir, 9X. So X is equal to 10 divided by 9. X is equal to 10 divided by 9. Okay. So means across this, how much is the potential difference? 10 by 9. Okay. Can you tell me how much is the potential difference across this? That is 2X. So that will be 20 by 9 volts. How much is the potential difference across this? You say, sir, that is 6x. That is 60 by 9. I hope you got it. I hope you got it. Yes, great, 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 great. Now, next. Yes, this question, also important. Find current in each resistor. Once again, guys, see, we say V is equal to I into R, Ohm's law. In case of parallel combination, could you please tell me what is same across all the resistors? We say, sir, voltage. We say, sir, let me write over here. I can write V divided by R is equal to, sir, I. In parallel combination, we say voltage is equal to same across all resistors. Voltage is equal to same across all resistors. Okay. If voltage is same, this is constant. Can I say so I can say current is inversely proportional to the resistance. 110%. Current is inversely proportional to the resistance. So means the one which has got more resistance has got less current in it. So the one which has got more resistance, that is 8 ohm, will have less current in it. It is obviously common. Why would the current prefer to go through the high resistance path? So we say, let's suppose across this, if I say resistance is X, how much will be the resistance across this? We say, sir, it will be 4X. Because 2 is how many times smaller than 8? 4 times. So we say if it is X, this will be 4X. Now guys, we say this current 10 ampere, this is the net current. It is divided into I1 and I2. We say, sir, net current is divided into I1 plus, we say, sir, I2. And this is 10 ampere is equal. I1 in this case is X, I2 in this case is, we say, sir, 4X. So we say 10 is equal to 5X and X in this case is, we say, sir, 2 ampere. Now, if X is 2 ampere means this is the I1. So 2 ampere current will flow through 8 ohm. How much will be the current through 4 ohm? So we say, sir, I2 in this case will be, that is 4 into 2. That is 8 ampere. See, 10 ampere is coming. 2 ampere is going in this one. 8 ampere is going in this one. Yes, great. Okay, find the value of current. Find current. Find current in 5 ohm resistor. 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 Tell me guys, what is the current in the 5 ohm resistor? Solve this, give it a shot. Okay. First, okay. See. Let's do one thing. Let's redraw the circuit. Let's redraw. Okay. Let me show you how to redraw the circuit. I want you guys to interchange the position of this resistor and this battery. Take this resistor over there, battery over there. So I can make it something like this. This is the resistance. And I would say this is the battery. Okay. This is 5 ohms over here. And this is 20 volts over here. Okay. And then the second branch, I'll make it as it is. I will make it as it is. Then you have this battery, something like this. And then we say, in this case, you have got the third battery over here. You make it as it is. You make it as it is. Okay. Now, guys, this is 4 ohms. This is 10 volts and this is 8 volts. Tell me one thing. In the last class, I have shown you the technique to assume the potential 0 at some point. Here, we are assuming 0 volt at this point. Sir, how lot of students have actually asked me, sir, how do we get to know which point we are supposed to take the potential 0 at? It depends, guys. It depends upon the situation. In different situations, you might, like if I take the potential 0 over here, that will help me to solve the question. Sir, how will we be able to find it? The more you practice, the more you will get to understand that. Now see, if I am assuming 0 volt potential at this point, now see, I'll tell you how does it help me. We say if 0 volt is potential over here, we say, sir, 0 volt will be over here also. 0 volt will be over here also. Now see, if 0 volt potential is at this point, this is 10 volts. Can you tell me how much is the potential of this? This will be minus 10 volts. Why? Because see, I'm making the battery over here. This is 10 volt battery. This is having how much potential? We say 0 volts. We say always this is the higher potential and this is lower potential. We say higher potential, let's suppose this is VB. This is, let's suppose, VA. VB minus VA is always equal to this delta V. Higher potential minus lower potential is always equal to this potential difference. Now, higher potential is what? This is 0 minus. Lower potential is what? That is what we are supposed to calculate. Delta V is how much? That is 10 volts. So, VA will come out to be minus 10. That's the reason I told you this point has got minus 10. Okay. That's the reason this point has got minus 10 volts potential. But let me keep it here only. Now see, if this point has got minus 10 volt potential, listen, this point has got 0. Potential difference is 8. Can you tell me what is the potential difference of? Can you tell me what is the potential difference of this end? You say, sir, potential difference of this end will be, sir, plus 8 volts. Because higher potential, 8 minus 0 will be 8. Okay. Now, if this has got 8, this will also have got 8 volt potential because it is directly going to lay over here. If this has got 8 volts potential, listen to me very carefully, my dear friends. This is 0. This is 20. How much will be the potential of this point? How much will be the potential of this point? Sir, potential of this point has to be 20 volts plus 20. Why? Because 20 higher potential minus lower potential should be equal to this. 20 minus 0 is equal to 20. I hope you got it. And in this case, 0 minus of higher potential minus lower potential. Lower potential is minus 10 is equal to 0 minus of minus 10 is plus 10. See, it is coming equal to plus 10. Okay. That's the reason I made the potential 0 at this particular point. So it helped me to draw the potential of all the points of the system, of this figure, of this circuit. If I say I will make the potential 0 at this point, it is difficult for me to tell the potential at this point in that case. Because you can't say, sir, potential at this point is something, then you will assume potential at this point something. No. That's the reason. The more you practice, you'll get to understand at which point I'm supposed to take the potential 0. Okay, tell me in the chats, guys. Tell me in the chats. Yes or no? Tell me in the chats, guys. Yes or no? Tell me in the chats. Simply, I'll explain this once again. What I'm trying to say is that assume 0 volt potential at this point. If this is 0 volts, this end will have the potential of minus 10. If this is 0, this end will be also having 0. So this end will have the potential of plus 20. If this is 0, this end will be also having plus 0. And then this end will have plus 8 volts. If this is plus 8, this will have plus 8. Even this point will have plus 8. Even this point will have plus 8 volts potential. Okay. Now. This is very important question. This is very important question. Killer question. Now see. If I ask you to tell me the potential in 5 ohm resistor, a current in 5 ohm resistor, you say, sir, this is 5 ohm resistor. I'll write over here. Current in 5 ohm. So you say, sir, you have got the 5 ohm resistor over here. And this is 8 volt potential from this side. And from the another side, this is 20 volt potential. This is 5 ohm. 5 ohm. Sir, how can we find the current in this case? We say, sir, current is equal to delta V divided by R. Sir, what is delta V? Delta V is higher potential minus lower potential. That is 20 minus this 8 divided by R is 5. So how much is that? That is 12 by 5 ampere. So in this case, let's call this as current I1. In this case, this branch is having the potential. This branch is having the current of 12 by 5 ampere. Okay. Now, one more important thing let's add over here. If this has the current of 12 by 5 ampere, can I say, listen to me very carefully. Sir, this I1 is coming over here. Some part of the I1 is entering this. Let's call that I2. And some part is going in the downward direction. Let's call that I3. Yes. Can you find the value of I2? So let's find I2. To find I2, let's find the value of I2. Take this resistance over here. Take this resistance over here. Okay. Now, this end has got plus 8 volt potential. This end has got minus 10 volt potential. And this is 4 volts over here. And in this case, if you find the value of current, that is delta V by R. What is delta V? 8 minus of minus 10. Higher potential minus lower potential. Divided by R is 4. So that is 18 by 4 ampere. So I2 is 18 by 4 ampere. I2 is 18 by 4 ampere. Okay. Similarly, you can even calculate the value of I3. See, I is equal to I2 plus I3. Can I just write it? I can write over here as we say I1 is equal to I2 plus I3. You got the value of I1 and I2. Can you write, sir, this is I1 and then you write, sir, minus I2. This will give you the value of I3. Just put the values and get the value of I3. Okay. So it was a very beautiful question. This was a very beautiful question actually. Let's talk about this one. I'm writing the question, find the current in, we say 2 ohm resistor. Find the current in 2 ohm resistor. Come on, tell me. Find the current in 2 ohm resistor. See, what I'll do over here is, see, this circuit is grounded over here. Grounded means 0 volt potential is over here at this point. If this is 0 volt potential, this means grounded means 0 volt potential. 0 volt will be here. If this is 0, this is 8. Can I say this will be plus 8 volts? 8 minus 0 is 8. Now, if this is 8, how much is the potential? How much should be the potential of this so that difference comes out to be 4? We say, sir, 4 volt. See, 8 minus 4, higher potential minus lower potential. 8 minus 4 is 4. See, it is 4. See, difference of these two should be equal to this. That's what my motive is. Okay. That's what my motive is. Now, guys, this is 6 volts. What should be the value of this point so that it comes out to be 6? See, this is 4. If I place minus 2 volts over here, see, higher potential minus lower potential is this. Higher potential is 4 minus lower potential is minus 2. 4 minus of minus 2 is 6 volts. See, correct. If you say it is plus 2, 4 minus 2, then it should have been 2. Okay. Now take this 2 ohm resistor. Take this 2 ohm resistor. This is 2 ohm resistor. And in this 2 ohm resistor, you are supposed to find the current. This is plus 8 volt. This is minus 2 volt. So we say current in this case is delta V divided by R. What is the value of delta V? Delta V is, sir, 8 higher potential minus lower potential. 8 minus of minus 2 divided by 2. So this is 10 by 2, that is 5 ampere. So in this case, current came out to be the 5 ampere. Okay. Okay, tell me the answer of this question. Find current through 10 ohm resistor. This is, we have got one battery, its another resistance, internal resistance, another battery, its resistance. You have to tell me find the current through this 10 ohm resistor. Find the current through this 10 ohm resistor. Hello? Hello? Yes, diesel. Hello? Huh? See, guys, if I say I have got a battery over here and then I am connecting a resistor, this is 10 ohm resistor and this is 10 volt battery. If I say tell me the current in this case, you say, sir, current is V divided by R. V in this case is 10 and R is 10, so we say, sir, 1 ampere. But right now, I am not giving only one battery, I am giving the two batteries. Two batteries we have over here. So we say we'll first find the equivalent of these two batteries, net EMF. Then we'll find basically so I can say current in this 10 ohm resistor. See, how do I write? Current in this 10 ohm resistor will be, sir, E net potential difference upon, we say, sir, resistance upon this 10 ohm. Okay. Now let's first find the net E net over here. I have told you in the last class how to find the E net in case of two batteries. We say, sir, E1 by R1. So what is E1 over here? That is 5 divided by, what is R1 over here? That is 1. E2 by R2. Now see, polarity of the battery is changed. If you ever see something like this, see, in this case, this is the higher potential and this is the lower potential. This is the lower potential and this is the higher potential. Polarity is changed. Then you say you put the negative sign. Don't say plus. Put the negative sign. Minus E2 by R2. E2 is 10 divided by R2 is 2. Because what is the formula to find the net EMF in parallel? We say, sir, E1 by R1 plus E2 by R2 upon 1 by R1 plus 1 by R2. Okay. So E1 by R1 plus E2 by R2 upon 1 by R1. So that will be 1 upon 1 by 1 plus 1 by R2, 1 by 2. Now see, 2 ones, 2 5s. 5 by 1 minus 5 by 1. So this will come out to be 0. So net potential difference in this case is 0. If E net is 0, so can we say, sir, current will be 0? So no current will flow in the 10 ohm resistor. This is where you made mistake. The polarity is changed. The polarity is changed. Is this clear, guys? Is this clear? Let's talk about this. Let's talk about this. We have got resistance connected in parallel to this particular battery over here. And the resistance is given as 1100 ohms. Guys, we are supposed to find the current in the ammeter. Find the current, how much current can flow through the ammeter. I can simply say one thing in this particular case. Sir, what is that? Listen to me very carefully. Let's suppose we have got this resistance over here. Okay, and we are connecting a battery to this resistance. This is 220 volts and this is resistance R is equal to 1100 ohms. Okay, R is equal to 1100 ohms. 220 volts, 1100 ohms. Can you tell me current in this? You say, sir, current is V by R. V is 220. This is 1100. Okay, that is 1 by 5 ampere. That is 1 by 5 ampere. Simply. So means, guys, this battery is connected to this resistance. It is giving the, how much current? We say, sir, 1 by 5 ampere. Now, this resistance is also directly connected to the battery because they are parallel. So here also it will send the same current, that is 1 by 5. We say in this case also it will send the same current 1 by 5. In this case also it will send the same current 1 by 5. In this case also it will send the same current 1 by 5. Now tell me one thing. Sir, we say current always flow in the loop. This current will flow in this loop. The second current will flow in this loop, something like this. The third current will flow in this loop and crosses the ammeter. This current will also flow in this loop, crosses the ammeter. This current will also flow in the loop, cross the ammeter. So can you tell me current passing through the ammeter? Current passing through the ammeter will be how much? We say, sir, that is 1 by 5 plus 1 by 5 plus 1 by 5. That is 3 by 5. 3 by 5 amp. This is the question. I've shown you so many questions on midpoint potential. This I'll give you as homework. You have to do nothing. Simply assume remove this. First of all, you will be removing this one and removing this one because these are the open circuits over here. No current will flow through this resistor. So we remove it. Then you assume the potential 0 at this point. We assume 0 volt. If this is 0, how much will be this point? How much will be the potential of this? Will be 2 volts. If this will be also 0, this will have plus 2 volts. If this is 0 volts, this will be also having plus 2 volts. Okay. Now find the potential of this end. So V common will be, sir, V1 by R1. V1 divided by R1 plus V2 divided by R2 plus V3 divided by R3 upon 1 divided by R1 plus 1 by R2 plus 1 by R3. This is the formula that you will be using. Okay. Now, what is V1? V1 is the potential of, if you consider this as R1. This is V1 and R1. So I can write over here, this is 2 divided by 1 plus. This will be also 2 divided by 1 plus. This will be 2 divided by 1. 2 divided by 1 upon 1 by R1. That is 1 by 1 plus 1 by 1 plus 1 by 1. Tell me, is this clear? So we say this will be over here 6 by 1 upon 3 by 1. So how much will be the final answer in this case? 2, huh? Okay. I hope you got it. Is this clear to each and everyone? Tell me in the chats, guys. 2 is the final answer, huh? Okay. So we are done with this. Now we have the next question over here. Take a look at this particular question. This is a very beautiful question. This is a very beautiful question. There is nothing much to explain in this particular question. See, it is simply, I am assuming 0 volt potential at this point. So this will be also having 0 because straight wire, this will also have 0. If this is 0, I have made a mistake. I have made a mistake. Guys, if this is 0, the battery is 1 volt only. If this is 0, battery is 1 volt only. So this will be 1 volt plus 1 volt. Why didn't you tell me? If this is 0, this is 2, this is plus 2. And if this is 0, this is 3, this has to be plus 3 volts. Yes. 1, 2, 3. No. Okay. Guys, this is 0 volts. This is 1 volt is the potential difference. How much should be the value of this? 1 minus 0 is 1. 2 minus 0 is 2. 3 minus 0. This is also 0. 3 minus 0 is 3. And this is, we say, sir, V common. And in this case, we say, this resistor, 10 ohm and 10 ohm. These are the open circuits over here. Current flows in the loop. Current does not flow in the open wire. So remove these, remove, and remove this also, okay? Now you have to find the potential of this point. You will use this formula, V1 by R1. What is V1? That is 1 by 1 plus. Then we say in this case, 2 by 1, okay? Then we say plus 3 by 1, okay? In this particular case. 1 by 1 plus 2 by 1 plus 3 by 1 upon, we say, sir, 1 by 1 plus 1 by 1 plus 1 by 1. Is this clear now? Is this clear now? I have made a mistake previously. Is this clear now? Is this clear now? Now this is 3 plus 2 plus 1 is 6. 6 by 3. Now it is 2 volts. Is this clear? Tell me in the chats, everybody, guys. All the people out there, let me know in the chats if this is clear. And if you have not liked this session, like it as soon as possible. Next question on the screen. Next question on the screen. Yeah, solve this question. Tell me the answer of this question. I'm reading your comments over here. Tell me the answer of this question, people. Everybody. Now see. I'll make you this understand. I'll make you this understand. See. Listen to me very carefully. A filament bulb, 500 watt. Okay. A filament bulb, 500 watt. We have got a bulb over here. Okay. This is 500 watt, 100 volts. 100 volt means it has, this is, we say, sir, rated voltage. If you give the 100 watt to this bulb, it will give you, if you give the 100 volt to this bulb, it will give you the 500 watt. It will give you the 500 watt power. Okay. Okay. Is used in a supply of 230 volts. Okay. There is a supply of 230 volts mains connected to this, and a resistance is connected to this in series. Resistance is connected to this in series. This is R. Okay. Now, my dear friends, listen to me very carefully. If you have got a bulb over here, what is the maximum voltage it can take? That is 100 volts. That is 100 volts. Sir, what if we supply greater than 100 volts? We say in that case, this bulb will burn. Okay. So 100 volt is the maximum supply that we need to send over here. Okay. Then you see, guys, if we say we are supplying the 230 volts, we say we have got the resistance in parallel. So this will take how much potential difference? This will take 100 volts only. So rest of the 130 volts will go into the resistance. And we are supposed to find the value of this resistance only in this case. We are supposed to find the value of resistance in this case. Okay. Now see, how do we exactly solve this particular question? We say as, can you tell me first how much is the current in the circuit? We say, sir, power P is equal to V into I. This is also the formula for the power, V into I. Sir, what is power? Power in this case is given as 500 is equal. How much is the voltage in this case? That is, we say, sir, 100, and this is I. We are talking about the bulb only. Okay. So this and this will cancel. So I in this case comes out to be 5 ampere. If I in this case is coming out to be 5 ampere, listen, boys and girls. If I in this case is coming out to be 5 ampere. So we say, sir, now let's talk about this resistance. Can we say in resistance, we say, sir, V is equal to I into R. Okay. And we will talk over here, I is equal to V divided by R. What is the value of V? Sir, value in case of resistance is this. We are supposed to find the resistance. We say, sir, over here, resistance is equal to V divided by I. So what is the value of resistance of V over here? That is 130. Because it is taking the supply of 130 divided by current in this circuit is how much? That is 5 ampere. So this will be 5. If in the bulb it is 5 ampere, is in the series. So here also it will be 5 ampere. So this will be 26 ohms. So resistance will be 26 ohms. This is already done. Done yesterday. In the marathon, we are done with this question. Let's talk about this question. Let's talk about this question. Let's talk about this question. A, B, C are the voltmeters of resistance R. A, B, C are the voltmeters of resistance. This is having the resistance R. This is having 1.5 R. That means 3 by 2 R. 3 by 2 is also 1.5. And 3 R respectively. This has the resistance 3 R. Okay. Then it says that potential difference across this is VA. Potential difference across this is VB. Potential difference across this is VC. We are supposed to find what is the relation between potential difference across VA, VB and VC. What is the relation between their potential differences? Okay. Guys, listen to me very carefully. We have got the 3 voltmeters. This one and this one. Their resistance is given. Voltage is given. We have to find the relation. Tell me one thing. Guys, this is resistance R. This is resistance 3 by 2R and this is resistance 3R. Let me take these two resistors. If I say I have got a resistance, this is 3 by 2R and I have got one more resistance, this is 3R. Can you tell me they are equivalent? Sir, in case of parallel combination, we say, sir, R equivalent in this case will be R1, R2. R1 is 3 by 2R into R2 is 3R divided by R1 plus R2. That is 3 by 2R plus we say, sir, 3R. Now we can write it something like this. 3R into 3R is, we say, 9R square divided by 2, whole divided by, see, 2 into 3 is 6R. 6 plus 3 is 9R. This is 9R divided by 2. Now 9 by 2 will cancel, R and this will cancel. So R equivalent in this case will come out to be, we say, sir, R. So means, listen to me very carefully, my dear friends. Listen to me very carefully. Let's suppose I am drawing this point X. Okay, this point is X. Then we have got this resistance, we say, sir, over here, this is R. Let's make it as voltmeter. We have got this voltmeter A. It has got the resistance R. Okay. And then, my dear friends, equivalent of this is also R. Let's suppose that is also R. And this is the point Y, because equivalent of these two is R. If I say potential difference across this is, let's suppose, VA. Can I not say, sir, potential difference across this is also VA? Because same resistors. So across both of these, potential difference will be same. Guys, if this is R, this is R, we say potential difference across both is same. Now, if I say, listen to me very carefully, potential difference across this is VA. I am saying, sir, potential difference across their equivalent is also VA. So means I can say potential difference across this is VB. So this VB has to equal to VA. This has to equal to VA. And this VC also has to equal to VA. Because we calculated potential difference. See guys, this is X. Let's suppose this is Z. Across Z and Y, how much is the potential difference? VA only. So let's suppose this is Z. Across Z and Y, potential difference is VA. But we have given the name that is VB, VC. So I can say in this case, VA is equal to VB is equal to VC. Hey, tell me in the chats, is this clear? Tell me in the chats, is this clear? Everybody, I'm waiting. Tell me, is this clear? All the people out there. Tell me, guys. Some people are still confused. We say that we have got resistance R. This is point A. This is point B. We have got this resistance R. This is point C. If I say across this resistance, potential is V. Across this resistance, how much will be potential? Same V, because same resistance, potential will be also same. Okay. Because V is equal to I into R. The current in case of series is same, so V is directly proportional to R. So the amount of, if R is 10, V is 10, R is 20, V is 20. Now see. Listen to me very carefully. I say potential difference in this case will be same. Potential difference across each resistor in this case is same. If potential difference across each resistor is same, this is B and C. But in actual reality, listen to me very carefully. In actual reality, this was the equivalent of two resistors. I will make that over here. This was the equivalent of two resistors. That was this 3 by 2R and this 3R, this 3R. If I am saying across BC, voltage is V. So it means that across this point and this point also voltage is V. Across this point and this resistor, voltage is V. But in the question, across this resistor, voltage is given as VC. But we calculated that came out to be V. In the question, across this, it is given as VB. But we calculated that came out to be V. So that's why I'm saying, sir, if across this is VA, so VA is V, VB is V, VC is V. Now I hope you got it. If still not, this is the maximum experience of teaching I have to make you guys understand. That's it. Else leave this question. Let's come over here. The questions of magnetism. the questions of magnetism. Okay, starting the magnetism questions. Now see, my dear friends, find the potential B, find the potential, find the magnetic field at point P. We are supposed to find the magnetic field at this point P. We have got a wire in which current 2 ampere is flowing at 4 meters. We have to find the magnetic field. We know, sir, the formula for magnetic field is mu naught I divided by 4 pi r. Then we say sine of theta 1 plus sine of theta 2. This is the equation that we studied in the last class. So we say this is B is equal to mu naught. What is the value of I in this case? That is 2 ampere upon 4 pi. What is the value of R in this case? That is 4 meters. Then we say sine of theta 1, that is 30, plus sine of theta 2, that is also 30. That is also 30. Hey guys, tell me, is this clear? Is this clear to each and every one? Okay. So we say, sir, 2 ones, 2 twos. So B is equal to, we say, sir, mu naught by 4 into 2 is 8 pi. And then we say sine 30 is 1 by 2 plus we say, sir, 1 by 2. 1 by 2 plus 1 by 2 is 1. So magnetic field comes out to be mu naught upon 8 pi. Or you can also say this is 1 by 2 of mu naught by 4 pi. So the value of mu naught by 4 pi, always remember it is 10 raised power minus 7. Yes. So it is, so 1 by 2 is 0.5 into 10 raised power minus 7 Tesla. Is that clear? Is that clear? Great, great, great. Next question we have over here. See, in this case, this angle is given and this angle is given. We don't know this angle and we don't know this angle. This was theta 1, this was theta 2. Tell me one thing, guys. If we talk about this particular triangle, this is the angle 90. Can we say one thing? Guys, see. What is the sum of all the angles in the triangle? That is 180. So we say this is 90. We say 90 plus this 30 plus, let's call this as theta 1. Theta 1 is equal to 180. Sum of all the angles is equal to 180. Now see, 90 plus 30 is 120. So 120, I'll write over here. Theta 1 is equal to 180 minus 120. So theta 1 will come out to be 60 degrees. So this is, we say, simply 60 degrees. And if this is 60 degrees, we say this is simply 30 degrees over here. Okay. Okay. Yes. Now. Let's find the magnetic field. We say, sir, magnetic field is equal to mu naught I divided by 4 pi r. Then we say sine of theta 1. So what is theta 1 in this case? That is 60. Sine of 60 plus we say, sir, sine of 30. Now put the values of sine 60 and sine 30 and get the answer of this question. Get the answer of this question. We have got this question. Next over here. Find the magnetic field at the center P. Find the magnetic field at this point P due to the infinitely long wires. We have got the two infinitely long wires over here. Okay, this is the infinitely long wire. This is the infinitely long wire. Okay, we are supposed to find the magnetic field at point P. Guys, listen to me very carefully. If I say magnetic field because of this wire at this point, place your thumb along the direction of current and curl your fingers. So we say at this point magnetic field is inwards. Let's suppose that is B1. Similarly, we say magnetic field because of this wire, place your thumb along the direction of current, curl your fingers. So magnetic field at this point will be outwards, that is B2. Okay. So both the magnetic fields are opposite. So I can simply say in this case, our net magnetic field is B1 minus B2. Why? Because they are opposite. If they are in the same direction, we would have added them. Now, how much is the magnetic field because of the infinitely long wire? Can anybody of you tell me in the chats out there? How much is the magnetic field because of the infinitely long wire? Sir, magnetic field because of the infinitely long wire is mu naught I divided by 2 pi r. Now, because of this wire, it has current 5 ampere. So we say I1. Then minus at r distance we are finding. Magnetic field because of this wire, that is mu naught I2 divided by 2 pi r. At r distance we are finding. Now guys, we say sir, take mu naught divided by 2 pi r. We'll take this common. And then we say I1 minus, we can say I2 over here. What is the value of I1? I1 is 5 ampere. So I'll write over here, this is mu naught upon 2 pi r. What is the value of I1 over here? That is 5 ampere. So I'll write 5 minus. What is the value of I2? That is 2.5. And more importantly, this R has value of how much? If the whole distance between separation is 5 meters, this is how much? 2.5. So this is also 2.5. So 5 minus 2.5 is 2.5 and 2.5 will cancel. So answer will come out to be mu naught by 2 pi. Mu naught by 2 pi. Mu naught by 2 pi. Okay, this question. A straight wire of finite length carrying current I subtends an angle of 60 degree at point P. Subtends an angle of 60 degree at point P. Okay. We have got a wire. Let me make the wire over here. We have got a wire over here. Okay. We have got a wire over here. And in this particular case, listen to me very carefully. It is basically making an angle of, we say 60 degrees over here. Okay. This angle is basically 60 degrees. This length is given as X. Wire is this much only. This is the wire only. These are not the wires. Okay. This is the distance. This is given as current I is flowing. Now, my dear friends, we are supposed to find the magnetic field at this point P. Okay. See, if I join this point with the wire, can I say, sir, this angle is 30 and this angle is 30? Both are 30 degrees over here. Yes. And let's suppose this is R over here. This distance, perpendicular distance is R. If we have to find the magnetic field at this point, what will we say? B is equal to mu naught I divided by, we say 4 pi R. Then sine of theta 1, we say sine of theta 1 is 30 plus theta 2 is also 30, sine of 30. Sine of 30 plus sine of 30. Okay. So we say sine 30 is 1 by 2. I can write over here B is equal to mu naught I divided by 4 pi R. Sine 30 is 1 by 2. 1 by 2 plus 1 by 2 is 1. So remove it. So it will be 4 pi and R. Now the question is, what is the value of this R? Listen to me very carefully. Take this triangle from this triangle. Can you tell me what is the value of cos of 30 degrees? Sir, cos means curly black here, base by hypotenuse. What is base? Base is R and hypotenuse is X. So cos 30 is root 3 by 2. So multiply this X with this. So R will come out to be X root 3 divided by 2. Now place it over here. Now place it over here. So we can write, sir, B is equal to mu naught I divided by 4 pi. Instead of R, can I write root 3x by 2? We say, sir, root 3x divided by 2. 2 ones, 2 2s. So it will be mu naught I divided by, we say 2 pi root 3 into x. 2 pi root 3 into x. Is this clear? Is this clear to each and everyone? Tell me, guys. Is this clear to each and everyone? It is, I guess, matching with the option A. It is, I guess, matching with the option A, huh? Let's solve the next question. Okay, tell me in this case, what is the magnetic field at point P? What is the magnetic field at point P? Tell me, guys. Come on. Tell me how much is the magnetic field at point P? See, guys, in this particular case, we say the wire is still over here only. Wire is still over here only. Okay. Now, previously we were saying that, let's suppose if we have this wire, we are supposed to find the magnetic field at this point. Okay, this was the perpendicular distance. Join this point with one end of the wire, join this point with another end. We say this was theta1, we say this was theta2. This we were discussing previously. This we were saying previously. Now in this case, if you have to find the magnetic field, so we say join this with one end of the rod. Okay. So let's suppose this is, we say, sir, in this case, theta1, and join this with another end of the rod that's over here, and we call this as over here, we say theta2. This is theta1 and this is theta2. In this case, we say, we are assuming, guys, we are assuming the rod is still over here, but in reality, rod is still over here only. So see what we write in this case. We say magnetic field is equal to mu naught I divided by 4 pi r. R is the perpendicular distance. Then we say sine of theta1. Then we write minus sine of theta2 in this case. We don't write plus sine of theta2. Why? Because the rod is present till over here only. So for theta2 angle, we are subtracting it. Guys, if theta1 angle is from this point to this point, so we have to subtract from theta. Guys, see, what I'm trying to say in this case is, this is the total angle, okay? If you subtract this much from total angle, means you are getting this much angle. Means you are getting this much angle. So that's what I'm trying, that's what is the actual purpose. So this much is the rod only. So that's why we are subtracting in this particular case. I hope you got it. I hope you got it. There is nothing much to understand in this one. This is the question next we have over here. This is the next question that we have over here. See, find the magnetic field at point B. We have got a semi-infinite wire. We have got a semi-infinite wire. Okay. We are supposed to find magnetic field at point B. See, let's suppose current in this case is flowing something like this and it flows something like this. My dear friends, if we have to find the magnetic field at point B because of this wire, if we have to find the magnetic field at point B because of this wire, what do we say? We say, sir, magnetic field is equal to, listen to me very carefully. Listen to me very carefully. We say, sir, magnetic field because of this wire is equal to, we say mu naught I divided by 4 pi and this r, 4 pi r, then sine of, what is the value of theta1 in this case? Listen to me very carefully. We say, sir, 45 degrees plus, then we say sine of 90 degrees. Why? I see. If I'm taking this, let's suppose I'm taking this wire. Okay, or let's take this wire. Let's suppose I'm taking this wire. Guys, in this case, we say, sir, theta1, join this point with one end of the rod. Sir, that end is at infinity, so you have to make the line something like this. So this will be theta1. Theta1 is 90. Join this point with another end of the rod that is over here. So this angle is 45 degrees. So right over here, sine of theta1. So let me say it's something like this. We say sine of 90 degrees plus we say sine of 45 degrees. Okay. Yes. So we can write over here B is equal to mu naught I divided by 4 pi r. Then we say sine 90 is 1 plus 1 by root 2. Okay. And do one thing. Sir, this is the magnetic field because of one wire. So because of both, because of both the wires, can I say, sir, magnetic field will be simply 2 times the magnetic field this, that is mu naught I divided by 4 pi r. We say 1 plus 1 by root 2. Let's talk about this one. Magnetic field because of the hexagon. Magnetic field because of the hexagon. The current is flowing something like this in this hexagon. This hexagon is made up of how many wires? See, place your thumb along the direction of current. Thumb, curl your fingers, it is pointing outwards. So at the center, magnetic field is outwards. This hexagon is made up of 6 wires. Okay. Guys, tell me one thing. If we find the magnetic field because of one wire, let's find the magnetic field because of one wire. Then we'll multiply it with the 6 wires. Okay. So we say in this particular case, listen to me very carefully. Sir, magnetic field net in this case will be 6 times the magnetic field due to one wire. This is the logic. Now, don't you think if we find the magnetic field because of this wire, it looks like a triangle? And this angle in this case will be how much? 30, 30. Come over here. Because of the triangle, how much is the magnetic field? Because of the triangle at this point, magnetic field, not a triangle, because of this single wire at this point, center, magnetic field is mu naught I divided by 2 pi root 3x. Mu naught I divided by 2 pi root 3x. So we say in this case, we'll say same. That is B is equal to mu naught I divided by 2 pi under root of 3. Over there, this length was given as x. Here it is given as L. So I'll take this L and multiply it with 6. 2 1s, 2 3s. So it will be 3 mu naught I divided by pi root 3 into L. Is this clear? Tell me in the chats, everybody out there. Is this clear? Is this clear, guys? Let's talk about this one. We have got a wire over here, okay? And see, in the last class, I told you, if the point lies on the axis of the wire, then we say in that case, magnetic field at that point is 0. So at this point, magnetic field is 0. And over here, we have got 2 wires. In this wire, current is flowing something like this, current is flowing something like this. We are supposed to find the magnetic field at point P. So we say magnetic field due to 1 will be 0. Why? Because this point lies on the axis of this wire. If the point lies on the axis of the wire, then we say in that case magnetic field is 0. We say in that case magnetic field is 0. Okay, come over here. So we say magnetic field because of the second wire. Guys, see, this wire is going till infinity from one end. Another end is finite. So this is a semi-infinite wire. So we say magnetic field due to second one. So that will be mu naught I divided by 4 pi r. Because this is a semi-infinite wire. Because wire 2 is a semi-infinite wire. So because of the semi-infinite wire at r distance, magnetic field is how much? Mu naught I by 4 pi r. Okay, important question. Listen to me very carefully. Assume that these two are very close. These two wires are very close. We say there are 6 wires. This structure is made up of 6 wires. This is first one. and this is second one, this is third one, this is fourth one, this is fifth one, and this is sixth one. We say the current is flowing something like this. The current is flowing something like this. Now, my dear friends, listen to me very carefully. Listen to me very carefully. Guys, see, if I say, sir, magnetic field because of this first wire, this is second wire, because of first and second, they are passing through at center. This point is passing through the axis of these two wires. Assume that they are very close. So this point is passing through the axis of this first wire. This point is passing through the axis of the second wire. So I can write magnetic field due to first and magnetic field due to second is 0. Because center point is passing through the axis of the wire. Center point is passing through the axis of the wire. Now, what remains over here? This. Now it is a square. So now, it becomes a square. And we know magnetic field because of a square is how much? Magnetic field because of the square is how much? Okay, that we have calculated in the last class. So that is 2 root 2 mu naught I divided by pi into L. I guess this one. This is the magnetic field because of the square. Let me know if this is correct or incorrect, everybody. Okay. Let's talk about this one. Now see, in this case, my dear friends, we said 2I current is coming. Okay. I gets distributed in this one and I gets distributed. This is 2I current. I over here, then this current flows, and then leaves as a 2I, something like this. This is one wire. This is the second wire. This is third wire. This is fourth wire. This is fifth wire. And this is sixth wire. In this case, clearly we say, sir, this first wire and this fourth wire are passing through. This point is passing through the axis of these two wires. Okay. So we say magnetic field due to first one is 0 and magnetic field due to fourth wire is 0. What about the rest of the wires? Listen to me very carefully. Guys, this wire will create the magnetic field at this point in the inward direction. This will also create in the inward direction. But if we talk about this one, place your thumb along the direction of current, it will create in the outward direction, same as equal to this one. This will also create in the outward direction. Because of these two, we say magnetic field due to 2 and B3 are inward. And when it comes to the magnetic field due to the sixth wire and fifth wire, we say are outward. If they are outward, so we say what will be the net magnetic field? We say, sir, in that case, net will be 0. In that case, we say net magnetic field will be 0 at the center. Let's talk about this one. Let's talk about this one. Let's talk about this one. See. Find the magnetic field at the center O of the loop as shown. Okay. Guys, here we have got this structure, this. These are the wires. These are the straight wires. Because of this wire, magnetic field at the center will be 0. Why? Because this point lies along the axis of this wire. Magnetic field because of this wire at center will be 0. Why? Because this wire lies along this wire is at it is at this point. It is along this point is along the axis of this wire. Okay. Now, in this case, let's first, we say, sir, if we have to find the net magnetic field, we say net magnetic field will be, let's suppose this is the first structure, this is the second structure, and this is the third structure. That will be magnetic field due to first plus magnetic field due to second plus magnetic field due to third. Magnetic field due to first, due to second, and due to third. Okay. Sir, because of this chord, magnetic field due to a chord is mu naught I divided by, because of the chord, it is mu naught I divided by 8R. Because of a chord, magnetic field at the center is mu naught I by 8R. So mu naught I divided by 8. What is the value of R in this case? R for this bigger chord is 4 times of R. So I'll write 4R. Okay, then I say plus. Magnetic field because of the semicircle, it is, we say, sir, mu naught. It is, we say, sir, mu naught I divided by, we say 4R. R in this case is what? 2R. R radius of this semicircle is 2R, so we write 2R. Then we say plus. Magnetic field because of this chord, you say, sir, that is mu naught I divided by 8R, because this is a chord. So I can write it 8 4s are 32. I can write over here, this is mu naught I divided by 32R. Then we say plus. This is mu naught I divided by 8R. Then we say plus. This is mu naught I divided by 8R. Okay. So what you can take in this case common is, we say, sir, mu naught I divided by R. So it will be 1 by 32 plus 1 by 8 plus 1 by 8. You can simplify this and get the answer, okay? This is the logic. I hope you understood the logic. Okay. Let's move on to the next one. Yeah, here is the question. Question on your screen, boys and girls. Question on your screen. My feet are paining now. Okay. Notes will be shared in the Telegram channel. Notes will be shared in the Telegram channel. Sir, what is the weight age? Weight age of these chapters. Weight age of these chapters is very high. Weight of this chapter is 40 Newton, age is 40 years. Okay, let's solve this particular question over here. Let's solve this particular question over here. We say charge Q is uniformly separated on a thin ring of radius R. The ring is rotated about an axis with the frequency, the magnetic induction at this. Okay. It is saying that charge is uniformly, okay. It is saying that we have got a ring, okay. And on this ring, charge is uniformly distributed over here. Uniformly distributed over here, okay. How much charge? We say, sir, Q charge. And we rotate this ring. We rotate this ring. If we rotate this ring, we say, sir, I is produced. I is produced. Because whenever the charge flows, charge moves, current is being produced. So if current is being produced, it will create the magnetic field at the center. And because of the ring, how much is the magnetic field at the center? B is equal to mu naught I divided by 2R. I hope you remember this. Now, my dear friends, in this case, we are given the frequency. We are given the frequency. We are given the charge, but current is not given. Can I say as? We say, sir, current is equal to charge upon time. I is equal to Q by T. I is equal to Q by T. Okay. So we can say, sir, and one more important thing is, sir, time is equal to 1 upon frequency. So we can write over here, I is equal to Q into F. If you put 1 by T over here, if we put 1 by F over here, it will go and Q into F. Now put it over here. So magnetic field will come out to be mu naught QF divided by 2R. Mu naught QF divided by 2R. Okay. Now, next question, this one. Sir, we have got a semicircular ring. Radius of the smaller one is R. Radius of the bigger one is 2R. We are supposed to find the magnetic field at this center. Let's suppose this is the first one and this is the second ring. Okay. Listen to me very carefully. Guys, in this case, at this center, if we have to find the net magnetic field, we say, sir, net magnetic field at the center will be magnetic field because of the bigger ring, magnetic field because of the smaller ring. See. Guys, if we say curl your fingers along the direction of current, we say thumb is pointing inwards. So because of this ring, magnetic field is inwards. So we say this B1 is, we say inwards. Sir, because of this ring, curl your fingers along the direction of current, thumb is pointing outwards. Sir, we say this B2 is, we say, sir, outwards. So if we have to find net, we have to subtract them because they are in the opposite direction. They are in the opposite direction. Huh? They are in the opposite direction. Now, my dear friends, we say, sir, B net is equal to B1. Magnetic field because of this ring. We say, sir, because of the semicircular ring, it is mu naught I divided by 4R. And what is R in this case? R in this case is R only, 4R. Okay. Then we say minus. We say this is mu naught I divided by 4R. In this case, for the bigger ring, R is 2R. So we write 2R. So this will be 4 into 2 is 8R. So mu naught I by 4R minus mu naught I by 8R, it will be mu naught I divided by, we say, 8R. Okay. Okay. And if somebody asks you what is the direction of net magnetic field, direction will be the direction of the bigger one. So that is inwards. Because this is larger than this one. This is mu naught I by 4R. This is mu naught I by 8R. More is getting divided over here. Magnetic field at okay, we are supposed to find the magnetic field at this point. Okay, we are supposed to find the magnetic field at this point. See. Guys, you have got this wire 1, you have got this wire 2, you have got this wire 3. Clearly, we say in this case, sir, magnetic field due to wire 1 is 0. Why? Because this point lies along the axis of the wire. Because this point 1 lies, this wire 1 lies, this point lies along the axis of the wire 1. Now, in this case, can you tell me how much is this theta? Remember, this theta is 3 pi by 2. This theta is 3 pi by 2. Okay. Now, guys, there is one formula. There is one formula over here. What is that? If you have got, listen to me very carefully. I have told you previously, if we have got a segment of the ring, so let's suppose this is theta and this is radius r. Because of the segment of the ring, magnetic field at this point was B is equal to, we say, mu naught I divided by 2R, theta divided by 2 pi. This was the magnetic field because of the segment of the ring. Okay. This was the magnetic field because of the segment of the ring at this particular point. Why am I making the charge? I have to make the current. Okay. This was the magnetic field because of this ring at this center, where theta is the angle between this and this. Then we define, sir, for a semicircle, theta is 180. For a chord, theta is 90. Now, for this structure, theta is 3 pi by 2. Can I say magnetic field because of this will be, listen to me very carefully, net magnetic field is magnetic field because of 3, that is B3, plus magnetic field because of this 4, that is B2. So what is the magnetic field because of this? That is mu naught I divided by 4 divided by 2r, theta by 2 pi. Theta in this case is 3 pi divided by 2 into, we say, sir, 2 pi. Then we say plus magnetic field because of this wire. Magnetic field because of this wire. This is a semi-infinite wire. Because of the semi-infinite wire, we say magnetic field is, we say mu naught I divided by, we say 4r. Sorry, mu naught I divided by 4 pi r. 4 pi. Okay. Now we can say this pi and pi will cancel over here. 2 into 2 into 2. This is mu naught I divided by 3 times mu naught I divided by 8r. And we say plus mu naught I divided by 4 pi r. Okay. So what we can take common in this case is, we say, sir, net magnetic field in this case is, we can take common, that is mu naught I divided by r, and then we say in this case, we say 3 divided by 8 plus, or you can keep it like this only. It'll become complicated. There is no logic of getting them common. Okay. Mu naught I by 4, mu naught 3 times mu naught I by 8r plus mu naught I by 4 pi r. Okay. Is that clear, guys? Tell me in the chats. Is this clear? Is this clear to each and everyone? Is this clear to each and everyone? All the people out there. Is this clear? Is this clear? Let's talk about this one. If you have got a structure something like this, see, this point is passing through the axis of the wire. So magnetic field due to 1 is 0. This point is also passing through the axis of the wire. So magnetic field due to 2 is 0. So how much is the magnetic field because of this? Theta is equal to, we say 3 pi divided by 2. So we say magnetic field because of this will be mu naught I divided by 2r. Then we say 3 pi divided by 2 into 2 pi. Once again, it comes out to be mu naught I, 3 times mu naught I divided by pi will pi, that is 8r. Okay, same question like previous one. Now see. Now see, my dear friends. We say we have to apply the Ampere's law over here. What does Ampere's law actually say? Ampere's law says line closed line integral B dot dl is equal to mu naught times of I enclosed. Okay. I hope you remember the last statement in the last class. I have made you clearly explain this. Sir, we have to take the enclosed currents, those currents only which are inside the loop. This is the Amperean loop. So means we don't have to take I6, we don't have to take I5. So I can write closed line integral B dot dl is equal to mu naught times of I enclosed. I enclosed in this case is, we can say, sir, I1, I2, I3, I4. I1, I2, I3 and I4. Now the point is, we have to mention which one is positive and which one is negative. How do we do that? See. Let's suppose this I1 is going inwards. Because of this I1, if we say magnetic field, place your thumb along the direction of current, then curl your fingers. So the direction of magnetic field because of this I1, let's suppose this is B1. Tell me, this is the direction of DL. DL is the element. Direction of DL in this case is this one. Direction of magnetic field is this one. So we say B and DL are opposite. If magnetic field and DL are opposite, then we used to take current as negative. Now, sir, let's talk about I3. Let's talk about I3. Sir, I3 is inwards. I3 is inwards, okay? Sorry, outwards. Place your thumb along the direction of current. Then curl your fingers. So means because of I3, direction of magnetic field is this B3. Tell me, this DL and B3 are in the same direction, so we take I3 as positive. Similarly, this because of this I2 magnetic field will be, sir, opposite to this B2, and so this will be negative. Similarly, this will be once again positive. I hope this is clear. I hope this is clear. Is this clear, guys? Tell me in the chats, everybody. If with the fire emojis, if this is clear. It will take us now more than 30 to 40 minutes and we are done with this session. Okay. This was done in the last class. Done in last class. This was also done in last class. Done in last class. Okay. Done in complete physics marathon. We are find the flux through the ring. In this case, we are supposed to find the flux through the ring. Guys, because of this wire, magnetic flux from this side will be, we say inwards, and from this side it will be outwards. So we say net magnetic flux in this case will be 0. Number of field lines going in is equal to number of field lines coming out. So that's why 0. This, okay, this is the question. Now let's suppose we have the current which is flowing in the wire. Because of this current, we say magnetic field will be produced something like this. This will be magnetic field. This will be magnetic field. Okay. It is like it is in 3D. This is a wire and this is a ring. We say because of this wire, magnetic field will be something like this. Those will be also making the concentric circles. We say here, magnetic field lines. Here, magnetic field lines are not crossing the area of the ring, okay. So flux through the ring is 0. So flux through the ring is 0. So in this case, flux will be 0. Okay, in this case, see guys, if you have this solenoid, okay, in case of inductor or solenoid, remember always magnetic field is along the axis. Magnetic field is along the axis, okay. And if you place a sheet inside that solenoid, we say, sir, this field line is not crossing the sheet, but it is touching the sheet. So we say, sir, in this case also flux is 0. It is not crossing the sheet, so flux in this case is 0. Tell me in this case. Come over here. Can you tell me the answer of this question? See, we have got a wire in which current I is flowing, okay. My dear friends, we are supposed to find the flux through the loop. Now see, because of this wire, at different points, we say, what is the value of flux? Flux is equal to magnetic field into area. Now the question in this case is, guys, because of this wire, at this point, magnetic field will be more. At this point, magnetic field will be less. So magnetic field is changing as you are moving away from the wire. So we cannot directly put the value of magnetic field over here. We cannot put the value of magnetic field directly over here because magnetic field is not constant. As you move, like over here, magnetic field is something. Okay. So we say, what we can do in this case is we'll take a small strip in this case. Let's suppose I'm taking the small strip of width, we say, sir, dx, which is at what distance from this wire? Which is at x distance from the wire. Which is at x distance from the wire. Okay. Now, we say we will see how much is the magnetic flux through this wire. Sir, flux through the small strip. We say flux through the small strip. So can I say flux through this small strip will be also small? So that is, we say, sir, d phi is equal to. D phi is equal to. That is d phi is equal to. Now see, that is magnetic field into area. That is magnetic field into area. Sir, what is magnetic field in this case? Magnetic field is, we say, sir, B into, we say, sir, area. Now the question is, what is the magnetic field? Guys, from this wire at this particular distance, magnetic field will be constant. Through this strip, magnetic field will be constant. And because of the infinitely long wire, magnetic field is mu naught I divided by, we say 2 pi r. Mu naught I divided by 2 pi r. This is the magnetic field because of the infinitely long wire through this strip. And then area of this strip is what? We say, sir, area is L, length of this is L, dx is the width. So we say, sir, L dx. This is a square, this is a square. So this is also L. So this is L dx. Okay. Okay. Now guys, this is mu naught I by 2 pi r. Instead of r, I am writing x because we are finding at the x distance, So I'll write x. So I'll write over here x. Okay. Now, in this case, to find total flux, we integrate. To find total flux, we say we integrate. So that will be integration of d phi is equal to integration of mu naught I divided by 2 pi x. Then we say L dx. So we say this is phi total is equal to, we say this mu naught is out, current is out. We say L is out, 2 pi is out, and then integration of 1 by x, we say, sir, dx, because x is variable. Value of x at this point is a, value of x this point is a plus L. So we have to say from a to a plus L. These should be the limits. Why? Because we have to cover the whole loop. So from a to a plus L, a to a plus L. So I can write, sir, flux total in this case will be simply, let's move on to the next slide. That is simply, we say, sir, flux total will be simply, that is mu naught IL divided by 2 pi, mu naught IL divided by 2 pi. We say integration of 1 by x is log of x, okay, from a to a plus L. So total flux through this will be mu naught I into L divided by 2 pi. So we say this will be, put the upper limit, that is log of a plus L upon a. Is this clear, guys? Is this clear, guys? Tell me in the chats. Tell me in the chats, everybody out there. Is this clear? With the fire emojis, guys. With the fire emojis. And like this session if you have not liked. And there is the All India mock test series going on, okay? The link is in the description below. Join that. That is completely free of cost, okay? We are designing those mock tests for you people. So join that completely free of cost. And if it asks for the code, use my code YAWAR. If it doesn't ask for the code, you can directly join it. The link is in the description below. Okay. Now find the direction of the current. In this case, we are supposed to find the direction of the current. Use Lenz's law. Sir, the current is decreasing. We said the direction of the current is decreasing in the downward direction. We say, sir, because of this current, magnetic field over here is inward. We say, sir, magnetic field here is inward. This is primary magnetic field. This primary magnetic field is decreasing. So this coil will try to support the decreasing magnetic field. So it can only support if the current flowing is in the clockwise direction. So because of this current, it will create one more magnetic field that is also inward, that is secondary magnetic field. Because of this, magnetic field is inwards and is decreasing. So current will flow in clockwise direction, which creates the inward magnetic field, one more magnetic field, secondary, which will support the decreasing magnetic field. Because Lenz's law says that if magnetic field is decreasing, you have to support it. If magnetic field is increasing, you have to oppose it. You have to oppose it. Okay. Let's move on to the next one. You have got this. Find the direction of the current. Find the direction of the current. You have to find the direction of the current in this case. Now see, guys, in this case, this is current is constant. But if this is moving away from the wire, so means as you move away from the wire, we say magnetic field will decrease. So in this case, magnetic field, first of all, let's find the direction of magnetic field. Place your thumb along the direction of current, curl your fingers. So magnetic field is inwards. This is B, primary is inwards. And this is decreasing. So this coil will never want to decrease the magnetic field through it. So current will flow in the clockwise direction in this case, clockwise direction. Then only it will support the decreasing magnetic field. Then only it will support it will create one more magnetic field that is secondary, which is also inward, so it supports. So current has to be clockwise. What is the direction of the current in this case? Find the direction ABCD. In this case, we say, sir, current is 0. Why? Because magnetic field through this is constant. When magnetic field is constant, no current is being produced because this is a constant current. As this is moving away, so current in this case will be clockwise. As this is moving close, if this is moving close, listen to me very carefully. Because of this, magnetic field will be inwards, okay? And if it is moving inwards, so this B primary is increasing, okay? So this coil will try to decrease the increasing magnetic field. So we say in this case, current will flow in the anti-clockwise direction. So we say I is equal to anti-clockwise. Guys, if the current is anti-clockwise, then only it will create one more magnetic field. That is B secondary. That is B secondary, and that will be outwards. That will try to decrease the primary magnetic field. This is what I have taught you in the last class, okay? In detail, I have told you this in the last class. I hope you guys remember. Is this clear to each and everyone, guy? Okay. Now see, find the direction of the current. Find the direction of the current. Listen to me very carefully. Find the direction of the current. Find the direction of the current. Find the direction of the current. See, guys, if this magnet is moving away from the coil, in the last class I told you, sir, this coil will develop an imaginary magnet inside it. And we say south pole, north pole will be from this side, south pole will be from this side. Why? If the magnet is moving away from the coil, this magnet will try to attract it. This magnet will try to attract it. And if this magnet was going close to the coil, then we would have made over here south pole, because then it would have repelled it. It has to repel it. Now, if this observer sees north pole, then we say in that case current is anti-clockwise. So in this case, current is anti-clockwise. See directly. And if the observer sees south pole of the magnet inside the coil, then we say current in that case is clockwise. Tell me in this case, we say here current is decreasing. Here current is decreasing. Current is decreasing. This current is decreasing. Because of this current, it will create the magnetic field over here, which will be inwards. Okay. And this is primary magnet, and this will be also decreasing, because decreasing current will create decreasing magnetic field. Now guys, this magnetic field is decreasing through this coil. So this coil will create the anti-clockwise current. It will create clockwise current. Why? So that it will create one more magnetic field which is also inward. By closing this, curling the finger, it is inward. So that secondary magnetic field will support it. So in this case, current is clockwise. Current is clockwise. Okay. Let's move on to the next one. Magnetic flux through a circuit of resistance is 20 ohms. Resistance is given as 20 ohms. And flux changes from, it is saying that we have got a coil, and through this coil, magnetic flux is changing. So change in flux is how much? 20 Weber to 40 Weber, that is 40 minus 20, that is 20. Okay. Okay. And resistance of this coil is given as, we say, sir, 20 ohms. We are supposed to find how much is the charge passed through the circuit. Guys, I have told you in case of Faraday's law, sir, charge flown delta Q is equal to delta phi divided by R. If you have got a coil over here, you are changing the flux through that coil, current will be produced in this coil. Current will be produced in this coil. Current will be produced means EMF is produced. If current is produced, we say, sir, charge is flowing. How much charge is flowing? This much. Delta Q is equal to delta phi by R. How much is the change in flux over here? That is 20. How much is the resistance? That is 20. So this is 1 coulomb charge. Let's talk about this one. Let's talk about this one. A circular ring of radius R, okay, is given exact. Find the induced EMF in this case. Guys, we are given a magnetic field over here, okay. This magnetic field is changing. B is equal to B naught into T square. And in this magnetic field, we have placed a ring of radius R. We are supposed to find the EMF. We say, sir, EMF is equal to minus d phi divided by dt. D phi by dt. Now in this case, when it comes to the flux, listen to me very carefully. We say, sir, it is minus d by dt of flux. What is flux? Flux is basically B into A, magnetic field into area. Sir, how much is the magnetic field in this case? We say, sir, d by dt of magnetic field is, we say, sir, B naught into T square. Area in this case is, we say, sir, pi R square. Because the radius of this ring is, we say, sir, capital R, pi capital R square. So I say in this case, I'll write EMF in this case is simply, that is minus, see guys. We say, sir, area is constant. Take this area out. So minus pi R square. Okay. Minus pi R square. And in this case, we say, sir, B naught into T square. What is the differentiation of B naught into T square? D by dt of B naught into T square. Okay. So that will be 2 times B naught. So this will be minus pi R square and this will be 2B naught. So answer in this case is minus 2 pi R square B naught. Simple differentiation we have to do over here. Because differentiation, see, area is constant. Take the area out of differentiation. Then it remains B naught into T square. So power down, power minus 1. 2 times of B naught. 2B naught into 2B naught. Okay, sorry. 2B naught into T. 2B naught into T. 2 B naught into T. Okay. And it says at T is equal to 2 seconds. So this is the EMF right now. So at T is equal to 2 seconds, at T is equal to 2 seconds, at T is equal to 2 seconds, we say EMF in that case will be minus 2. This will be pi R square. This will be B naught and this will be 2. This will be minus 4 pi R square into B naught. Is this correct? Huh? Check it, guys, later on. Okay. Everything sorted. Tell me in the chats, guys, if everything is crystalline clear. Okay. Done. Let me know in the chats. Next question, we have got this one. Find EMF. Okay. We have got a magnetic field over here. Okay. And in this magnetic field, listen to me very carefully, guys. In this magnetic field, we have placed a rod. Okay. And this rod is moving with the velocity v. We are supposed to find the EMF in the rod. Whenever the rod flows in the magnetic field, whenever the rod moves in the magnetic field, we say, sir, EMF induced in that rod is, we say, sir, BLV. Such that I told you, B, L and V, all the three should be mutually perpendicular. If any of the two are parallel, then EMF is 0. Already discussed. If any of the two are parallel, then we say EMF is 0. Tell me in this case, we say, sir, guys, listen to me very carefully. Sir, this is L. This is, we say, sir, L. The length of this is L. This is 60 degrees. Can I say, sir, this will be L cos of 60 degrees? Yes, sir. And this will be over here, L sine of 60. This is L sine of 60 degrees. Now the question is, sir, this L cos is parallel to V. So because of this length, EMF is 0. So this is the length. This is the length. This is the length which will create EMF. So I say this is EMF is equal to BVL sine of 60 degrees. Why did I take this? Because this is parallel. This L sine 60, V and B, they are mutually perpendicular to each other. So this is parallel, because of this magnetic field will be 0. Okay. Can you tell me in this case how much is the EMF? We say EMF in this case is 0. You have got a semicircular ring in this case. Listen to me very carefully. Okay. See, when it comes to the semicircular ring, we take its effective length, join this end with another end. This is R. So L effective in this case is, we say, sir, 2R. And if this wire is moving, rod is moving in the magnetic field B, okay, we are supposed to find the EMF. You say, sir, this EMF is equal to BVL effective length. So you say, sir, BV2R, but this 2R is and V are parallel. So EMF in this case is 0. V and 2R are parallel. So I say EMF is 0. Because if any of the two are parallel, we say in that case EMF is 0. We say in that case EMF is 0. In that case EMF is 0. Okay. Let's talk about this one. In given arrangement, if given arrangement is moving, okay. This structure, I hope this is visible. I hope this is visible. Listen to me very carefully, guys. See, the structure is something like this. The structure is something like this. The structure is something like this. This is R and this is given as 2R. Okay. Now, my dear friends, this structure is moving in the magnetic field. This is moving in the magnetic field B with a velocity V. We are supposed to find the EMF induced. Guys, see. In this case, can I say this structure is made up of two parts? First part is this one and second part is this one. this structure is made up of two parts. Okay. Now listen to me very carefully. Listen to me very carefully. My dear friends, if we talk about this one, this structure, can you tell me what is the effective length of this part? Effective length of this part. So you say, sir, effective length of this part will be simply, sir, that is from this point 2r plus 2r. So we say L effective in this case is, we say, sir, 4r. So now, if this 4r is moving in the magnetic field, EMF will be induced. So we say EMF. Let's suppose this is the first part and this is the second part. EMF of first part. So that is EMF is equal to PV. And what is the effective length? That is 4R. BV4R. And my dear friends, in this particular case, if we talk about this part, what is the effective length of this part? This part also has the same effective length, 4R. So we say EMF of, we say second part. We say that is also EMF is equal to BV4R. EMF is equal to BV4R. Okay. So BV4R. Now, my dear friends, listen to me very carefully. If I have to make the battery, over here, listen to me very carefully, or leave the battery. Sir, we say this one, this is having the EMF BV4R, this is having the EMF BV4R. Guys, in this particular case, one thing I just want to tell you, EMF means potential difference. Battery has potential difference. So if I say EMF is BV4R, so means this rod as having the EMF, means this rod behaves like a battery. So instead of this rod, I'll make a battery over here. That will be something like this. That will be something like this. That will be something like this. So because of, instead of this rod, I'm making the battery over here. That is having the EMF of BV4R. Instead of this rod, I am having making the battery something like this. That will also have, sir, BV4R. Remember one more point, sir, what is that? I make the terminal, lower negative terminal from the upper side, higher potential from the lower side. Why? Because if you, let's see, sir, place your fingers along the direction of velocity, curl towards magnetic field. Magnetic field is inward from B to B. Thumb is pointing downwards. If thumb is pointing downwards, means lower one will be the higher potential, If I say it was moving along this, in that case, if I go from velocity to magnetic field, thumb is pointing in the upward direction, then I would have made upper one as higher potential and lower potential. Now guys, in this closed loop, can you tell me how much is the net potential difference in this closed loop? We say that will come out to be 0. EMF net is equal to 0. EMF net is equal to 0. Are you getting me what I'm trying to say? Is this clear? Because guys, if you move from, see, I'll show you over here. This is BV4R. This is BV4R. Let's suppose you are selecting this path. Now tell me, in this case, guys, listen to me very carefully. You are selecting this path. If you start from this point, let's suppose this is VA. So first you will write the potential VA. Now you are moving from lower to higher. So means you take this potential difference as positive, that is BV4R. Then in this case, you are moving from higher to lower. You take this as, we say, sir, minus BV4R. Then once again, you reach the same point is equal to, we say, sir, VA. So can I say net in this case is 0? This and this will cancel. Net in this case will be 0. So that's what we were supposed to calculate in this case. Individually, this structure, if it is moving with the velocity V, how much EMF will be created in this one? And in the closed loop, how much will be the EMF? Net EMF is 0. I hope you are liking this session. I hope this. And we are done with this. Okay. In this I will give you as homework. Find the EMF of the structure. This I will show you over here. This I will show you over here. This I will show you over here. See, you have got over here, let's suppose magnetic field. In this magnetic field, you have placed this structure. The resistance in this case is R. The resistance in this case is, we say, sir, this is R. And this resistance is also R. This resistance is also R. Okay. Now guys, see. This resistance is R. This resistance is R. See. My dear friends, if this rod is moving in this structure, can we redraw this structure? So this will be something like this. This will be something like this. And then you have got this rod. This rod is moving with a velocity v. It has length L in the magnetic field B. Can you tell me, sir, if this rod is basically slidable? If this rod is moving in this magnetic field, we say, sir, EMF will be produced. So what is the EMF of the rod? EMF is, sir, BLV. EMF in the rod is BLV. EMF in the rod is BLV. Okay. If in the rod EMF is BLV, listen to me very carefully. Now, can I say, sir, this is the resistance, this is the resistance, and now this behaves like a battery over here. This has BLV EMF. So this is R and this is R. We are supposed to find the current in the rod. We are supposed to find the current in the circuit. Guys, see, this is R and this is R. R and R are parallel to each other. So their equivalent will be, sir, R divided by 2. Their equivalent will be R divided by 2. So this is, sir, BLV. Now, can you tell me current? So current is V divided by R. What is the value of V? Or this is delta V, potential difference. So this is the potential difference, or EMF, BLV divided by. What is the equivalent resistance in that case? That is R by 2. So this will be 2 BLV divided by R. 2 BLV divided by R. Simply, first you find the EMF because of this. Then you apply I is equal delta V by R and find the equivalent resistance. Put this over here. This will be the current in the case. This also I have shown you so many questions on this. This also I'll be giving in the homework. Now we have only 5 questions left. Let's talk about this current I1. Let's talk about this current I1. See, we have got I is equal to, listen to me very carefully, I is equal to 3a sine of omega t. We have got I2 is equal to 4a cos of omega t. And we are supposed to find the net current. How do we find the net current? With the help of the phasor diagram. If you remember in the last class, I have told you, sir, I1 means, let's make the current over here. This is, we say, sir, this is I1. I1 is 3a cos sine omega t. When it comes to the sine omega t current, we make it on this axis. Okay. I hope you remember. Cos omega t on this axis. Sir, minus sine omega t on this axis. Minus cos omega t on this axis. So this will be the I1 in this case. And how much is this? This is 3 ampere. Okay. And when it comes to I2, can we say, sir, this I2 we will make over here. This will be, sir, 4 ampere. Yes. Now, guys, what is the resultant of I1 and I2? We say, sir, resultant of I1 and I2 will be something like this, I net. Sir, how to find this I net? Don't say, sir, under root of something, because this is 4 ampere, this is 3 ampere. These are different. If this was 4, then I would have said root 2 of 4. See, so net current in this case will be, listen to me very carefully. We say under root of, that is this square plus this square. 4 square is 16. 3 square is 9. So this will be under root of 25. That is 5. Okay. So we say this will be 5. Now guys, could you please tell me how much is this angle? How much is this angle? You say, sir, take this triangle. Take this triangle. So can we say from this triangle tan of this phi, tan of this phi, if we say this angle is phi, tan of this phi is perpendicular by base. Perpendicular is this, take it over there. This is 4, base is 3. So that is 4 divided by 3. When is the value of tan as 4 by 3? Sir, take this. This is 53 degrees. This is 4, 5, 3. If you see in this triangle, tan theta is 4 by 3. So phi is equal to 53 degrees. So means, my dear friends, this angle is 53 degrees. This angle is 53 degrees. Now take a look. Now take a look. Now take a look. I need to show you something. Guys, this is the peak volt. This is the peak current of this one. This is the peak value. This is also the peak value. And we are supposed to find peak value of this net current, that is 5. And how much is this angle? That is 53. Can I write, sir, this I net as its equation? Guys, this is I1 sine omega t. And then we say, sir, this current is how many times forward? This current leads this current by 53 degrees. So whatever is the equation for this current, we'll write the same here, but we'll lead it by 53 degrees. So we say I is equal to, how much is the peak value of this? 5. Then we say sine of, we say omega t, we say plus 53 degrees. Because it leads by 53 degrees over here, that's why we say this is sine omega t plus 53 degrees. This will be the net current in this case. I hope you got this one. I hope you got this one. Now this, let's suppose you have got this. I1 is equal to 3 sine omega t. This is we say, sir, I1. Okay. And most importantly, I write over here, this is 3. And you have got in this case, I2. I2 is equal to 3 cos omega t plus pi by 2. This is 3 cos omega t plus pi by 2. Okay. Now, guys, cos omega t was this one. This was cos omega t. This was cos omega t. Okay. Now see, this was cos omega t. Now we say this angle is pi divided by 6 over here. Pi divided by 6 means 30 degrees. So this is 90 plus 30 is 120 degrees. Means I can say over here, my dear friends, I can say over here, this total angle is 120 degrees. I1 is 3, I2 is 3, this is 1. Can you tell me what is the value of net current? That will be also 3. Because if this factor is F, this factor is F, net in angle is 120, net is also F. So this will be also 3. Now guys, tell me one thing. Guys, this will be exactly at an angle of what? At what angle this will be? We say, sir, 60 degrees. This will be at 60 degrees. So if we have to write the current, we say, sir, current will be I is equal to, we say, sir, 3. Then we say sine of omega t. Sine omega t will be along this axis plus 60 degrees. We say, sir, plus 60 degrees. This will be the net current in this case. This will be the net current in this case. Let's move on to the next one. Can you tell me in this case? Guys, I1 is equal to, see, this is sine omega t. Along x-axis, this is sine omega t. Now what is this? 4 sine omega t minus pi by 6. So minus pi by 6, we say, sir, this one. This will be I1, that is 4. So this is 4 sine omega t minus pi by 6. This is I1 current. Then you have 4 cos omega t plus pi by 6. Sir, this is cos omega t. Sir, 4 cos omega t minus pi by 6. This is cos omega t minus pi by 6 will be from this side. Minus pi by 6 will be from this side. Okay. Okay. In this case, this is 4, and you guys are supposed to tell me, in this case, net current. This is your homework. This is, we are done already. This. Okay. One more important thing I just want to tell you over here. What is that? In an AC circuit, we are given an AC circuit, voltage is given as 100 sine of 100t, and current is given as, we say, 100 sine of, we say, 100t plus pi by 3. Listen to me very carefully. We are given an AC circuit. Listen to me very carefully, guys. Let's suppose we are given a DC circuit over here. This is the DC circuit. Battery is connected to the resistance. And in this case, if I say, my dear friends, listen to me very carefully. If I say how much is the power supplied by the battery or power lost, we say, sir, let's suppose voltage is V and this is, we say, sir, I. You will say, sir, simply it is V into I. This is the power in this DC circuit. Power means how much energy it is supplying to the resistor. Voltage multiplied by the current. Okay. Now, my dear friends, if we have got an AC circuit, this is an important question. Okay. If we have got an AC circuit, in that AC circuit, we say voltage is given this much. Like over here, voltage was 10 volt, current was 10 ampere. We say voltage is given in this case this much, current in this case is this much. Tell me how much is the power over here? This is the formula by which we can find the power in the DC circuit. This is the formula which will help us to find the power in the AC circuit. What is that? We say power is equal to power in AC circuit. We write power in AC circuit. We say, sir, P is equal. We say I naught divided by root 2. Or directly you write it something like this. We say IRMS into VRMS. Then we have cos of phi. Phi is the phase difference. Like over here, you have V into I. You have over here VRMS into IRMS into cos of phi. Like the question in this case, question is given. See, how to find IRMS? We know, sir, when it comes to the IRMS, that is I naught by root 2. So I can write over here, this will be I naught divided by under root 2. And we say, sir, this will be V naught divided by under root 2. And then we say, sir, cos of phi. In this case, guys, this is phi. What is the value of phi? Pi by 3. How much it is forward? That is pi divided by 3. Okay. Now, tell me one thing. Sir, in this case, we can write it. This is how much? This is 100. This is 100 by root 2. Current is given as peak value is 100. So 100 by root 2. And it is given in milliampere. So multiply it with 10 raised power minus 3. So it becomes in ampere. Okay, this is current. Then VRMS, V naught by root 2. What is the value of V naught? That is 100 divided by root 2. And then we say cos of pi divided by 3. Solve this, guys. This will come out to be 2.5 watts. 2.5 watts. This is how do we exactly find the power in the AC circuit. Okay. IRMS, VRMS into cos of phi over here. Directly. Okay. I hope this is clear. We have one more question and we are done with this session. This is your homework, okay? Okay. Guys, if the ones who have not liked this session yet, I want you guys to like this session as soon as possible. Because it is mandatory. Because it's mandatory. Okay. So thank you so much, people. I'll be sending this PDF in your in the Telegram channel, and my feet are paining right now. Okay, I need to leave. I need to sleep. I haven't slept from yesterday also. Okay, and now, guys, thank you so much. And I want you guys to comment afterwards. How was the session? How was each and everything? Okay, do let me know in the comments. Okay, do share each and everything. So thank you so much. Take care and bye bye. Okay, I am done with them. I would say kind of I'm done with the marathon of 18 hours, 12 hours yesterday, 6 hours today. Okay. It was very difficult. Okay. It was very difficult. So thank you so much, people. Take care and bye bye. Done with the marathon of 18 hours. Done and dusted each and every single thing. Okay. And thank you so much for this love and support that you guys are showing, okay, in the comments, in the live chat, every single time. Okay, now I need to go and sleep. Take care and bye-bye. See you guys now very soon. Okay. So, all right, people. Bye-bye. And do let me know in the comments how was the session, each and every single thing.